What do you think a good university should have to give you lifelong learning experiences?
That's a good question.
A good university should have
worldwide recognition program,
innovative pedagogy and interdisciplinary teaching approach,
best-in-class faculties with industry exposure,
modern state-of-the-art infrastructure, advanced lab facilities,
and wide industrial exposure for outstanding placements.
Dayanand Sagar University, a beacon of inspiration, quality, and wisdom. With a legacy spanning over 6 decades, the university is known as the pride of South Bangalore. Consistently rated as one of the top 3 universities in Karnataka, Dayanand Sagar University inspires students with unique perspectives and knowledge. And now, to inspire thousands more, the university expands its in-demand programs to the Kudlu Gate City Innovation Campus. Equipped with world-class infrastructure, industry-driven innovation laboratories, on-campus medical facilities, and multifaceted faculties, creating a whole new world of possibilities for the brilliant minds in the heart of Bangalore city.
The best thing about this campus is that it is easily accessible. It only takes 45 minutes for me to reach here from Indranagar. Some of my friends come here from Hosur and Whitefield.
DSU City Innovation Campus is so well placed that everyone in the city would love to access it.
The City Innovation Campus now offers coveted programs in commerce, management, arts, design, humanities, computing applications, law, and basic and applied sciences to help students explore the unexplored and discover new possibilities.
This part of the city has always been missing a prestigious campus with these courses, but now with DSU, this will be solved. DSU is the synonym of trust. The university employs industry experts and easily attracts national and international collaborations.
Due to its proximity to the IT hub of Bangalore, DSU is a hotbed for placements and industrial exposure, and also the preferred places for companies to set up the incubation centers.
Experiential learning or practical learning is right at the forefront of things when it comes to student activities.
The relaxed and cohesive environment attained through an engaging, innovative, and industry-aligned curriculum, a technology-driven campus, and innovation laboratories ingrain confidence in students to grab exceptional career opportunities, exemplifying the university's position as a premium university in placements.
In summary, Dayanand Sagar University offers facilities for the overall development, and I request the students to come and explore the opportunities.
DSU persuades us to aim big and to live dreams, and dreams are the most powerful energy. The values instilled at DSU will stay with us forever, and this is how I discovered my career should be.
Come, be a part of this journey to etch the bright future of the next generation. Dayanand Sagar University, live the dream.
Good evening all. So today we are here, we are winding up the sessions today. This is the last day for our Mind Spark series. And we are ending up with physics session, which will be till 8 o'clock. So students, I request you to be there and be with us in future also. We are soon to start with Learnodaya program. So for that, registration links will be shared to you soon on your mail IDs or on your WhatsApp numbers. So we'll start the session now. Vinay sir, are you here?
Yes, sir. Yes, sir. I'm here.
Yes, sir. We'll start the session now, sir.
Yes, sir.
Good evening, sir. Good evening.
Good evening. Good evening, sir. Good evening.
So you can start sharing your screen, sir.
Yes, sir. Good evening, students.
Just a minute, sir. Also, students, feedback form link I'm sharing in the chat box. Please fill it on priority basis. Yes, sir. You can start, sir.
Good evening, students.
Good evening, sir.
Good evening. Good evening. So yesterday we were discussing a question paper that you told that regarding certain chapters you are having doubts. So that's why I prepared a PPTs so that in middle, if you have any doubts in the concepts, so you can directly ask us. And as per the demand, you have asked regarding communication also. So I have an animated PPT, so that could be an easy to understand. So let's begin with the current electricity chapter. Later on, we'll shift it to optics. Then, as you demand attention nuclei, then we are going to discuss communication system. Okay.
Okay, sir.
Okay, fine. I don't know when to give a break. So if in case if you need a break, you just ask us. After the completion of at least one or two topics, I will give a break. Because yesterday I thought you all feel like continuous classes were there. I was involved in the classes, so that's why I forget the time. Let it be. Today it will not go like that. We'll start with the concept current electricity. So there will be prepared by 2 slides. So which is based on first concepts, that is current, Ohm's law, and EMF of the cells which are connected in series and also parallel. Is it voice is audible? Hello?
Yes, sir.
Yeah,
Yes,
okay,
sir.
fine. So we'll begin with the current electricity. As you know already, what is electric current? What is electric current? Anybody? The rate of flow of charges.
Charges, sir.
The rate of flow of charges. Okay, very simply, if you can define. So either the application of these will be in different field, because the current will be in different forms. One is that we call as direct current, where the potential or current remains constant. So another one is called as variable, that is called as AC current, alternatively variable current, that is called as variable current, alternating current. So there will be another one chapter, alternating current, that you are very well known, where we are going to discuss how this current going to be changes, which makes a modification in the flow of resistor, capacitor, and also in inductor coil. So here we are going to consider how this current will be flowing conventionally, how you are going to represent it. So you may know about that one. One second. So why it is. Done. So conventionally, how the current will be flowing. So conventionally, we thought like that from positive to negative, the current will be flowing. Conventionally, we represent. But actually, what thing happens? How the charges are flowing? Is that flowing from negative to positive or positive to negative?
Positive to negative.
Conventionally, we represent. But the thing is, actual thing happening is, from negative to positive charges are flowing. Clear? Conventionally, we represent current is flowing from positive to negative, but actually the thing happening is it is from negative to positive. Clear? Because of flow of charges from negative to positive, the current direction conventionally we consider as positive to negative. You need to remember this one. It could be asking for our MCQ question. Okay, so during this flow of charges, we come across to know about the drift current. There will be a concept called displacement current and drift current that you very well known in semiconductor chapter. Is it? Is it, student?
Yes, sir.
Drift voltage, drift current, and displacement current are different. Okay, let it be drift voltage. What it means is it's an average voltage with which an electron is or charges are flowing through the conductor with a constant velocity, that we average velocity. So that velocity which we called as drift velocity. So that could be find out by a relation, drift velocity is equal to a into time. So acceleration into time. So acceleration could be written in terms of electric field intensity and electric charge and mass of the electron. It is just simply by considering the Newton's law and electrostatic force. So here we obtain a relation between current and drift velocity, that is I is equal to NAE VT. So that I told you in the last class, I is equal to nowadays. So like that, you can easily remember the formula, which tells you if you are going to increase the current, what happens to the drift velocity. If you are going to increase the electric field intensity, what happens to the drift velocity. So that relation that gives by this expression. Okay, we'll move to the next slide where we are going to understand current density. So last class I forget to tell you about this one because the question was not arise. But the thing is, many of the question paper I found that this concept current density. What is meant by current density? So you know that charge density, you know that density of a substance. So how much mass in a given volume? What about charge density? How can judge charge density?
Sir, the amount of charge flowing per second per unit areas.
Area, yes, amount of charge flowing per unit area per second. So that we called as current density. So where in vector form we can consider is a current density is a vector or scalar. Current density is a vector or scalar. Anybody?
Vector, sir.
Current density is a vector, but current is a scalar. Current is a electric current is a scalar. Even though current has a direction, remember, even though current has a direction to flow, but it is a vector quantity because it doesn't obey vector addition. Clear? It doesn't obey vector addition. Okay, student?
Okay, sir.
Okay, fine. So we'll move to the next concept, that is Ohm's law. That is very well known, that rate of flow of charges, that is electric current in a conductor, which is directly proportional to how much potential difference applied between the conductor, keeping all other physical quantities constant, like temperature, mechanical stress, all those things will be remains constant. So using that one, we got an expression that V is equal to IR, where voltage and current which are linearly varying in a conductor. So that could be given by a linear expression. If you are going to consider for a semiconductor, how you can write it for a semiconductor? How you can write for a semiconductor? For semiconductor, it could be varying like this. It would be exponentially increasing. It should not linearly increasing, because when you're going to observe in semiconductor, there will be a p-type or n-type at initially a minimum voltage required to conduct. So that's why when you're going to consider for a semiconductor, it is not linear. It could be exponentially increasing. Okay.
Okay, sir.
Okay. One second. Okay. Now we got an idea regarding resistance. So we are going to understand a relation between resistance and resistivity. So what is resistivity? Can you remember what is resistivity? As like current density, there will be a concept called resistivity.
Sir, the resistance of a conductor of that material having unit length and area.
Unit length and area. Is that resistivity changes with length? Is it resistivity changes with length?
Sir, I exactly don't know, sir.
Yeah, you can see here in the formula, you can see what is resistance. Resistance is voltage per current, the ratio of voltage per current. We know the expression for current is NEAVD. So if you are going to substitute in the above equation, so we got an expression for V by I. So what is V by I will be ML NEA by T. T is relaxation time. So if you are going to solve this one, so R is equal to M into L divided by N E square T into A. If I'm going to modify this one, if I'm going to mention these values, because M is a mass of electron, N is number of electrons, E is charge of electron, and tau T is relaxation time. So if I'm going to if I'm going to substitute this one with a constant, so this constant, what we called as resistivity. Clear? Resistivity. So here, this resistivity of a material, which is depend on the material only, not with respect to length, with respect to area of cross section, because the definition itself says that resistivity is nothing but resistance offered by an unit length and unit area of cross section of a material. It could be copper, it could be zinc, or it could be a iron wire, any type of wire. So that's why resistivity, or we call it as specific resistance of a material, remains constant. If I'm going to say that we have 1 meter length copper and 1 meter length aluminum wire is there, is that both having the same resistivity?
No, sir. It
No.
will differ, sir.
It will differ. If 1 meter copper wire is there, 2 meter copper wire is there, is that has a resistivity same? 1 meter?
I think so, yes, sir.
Yes, 1 meter copper, 2 meter copper wire. That means the material doesn't change us, only the length is increased. If the length increases, resistance changes, but resistivity remains constant for a given material. Clear? Clear about this concept?
Yes, sir.
Resistivity. So resistance is different from resistivity or specific resistance. Okay. Now move to the next relation, that is a relation between drift velocity and current density, all those things. So here the some of the concepts which are linking one another. So resistivity is E by J, where E is in the what we call as a applied EMF, and J is called as current density. So that way is NEVD. So if you are going to observe that drift velocity could be represented as like that here, since E is equal to V by N. So applied EMF will be is equal to V by I, like that the ratio will comes. So if the temperature changes, drift velocity changes, current going to be changes. So these are the concept that interlinking the all one. Okay, fine. So we're going to understand next conductivity or conductance. What is conductance? Is a reciprocal of resistance. So where you're going to use mho, but SI unit is actually this unit is not a correct representation. Conductivity representation is conductance representation is Siemens. The SI unit of conductivity is Siemens. So that could be also represented as mho. It's a reverse of ohm, OHM, ohm per meter. It's a resistivity, means resistance offered by the unit length, unit area of cross section. Here conductivity is conductance offered by unit area of cross section, unit area of material. So hagagi, that's why we consider conductance and conductivity different. How this conductance changes with the resistance changes with the temperature. To understand this one, what happens if you're going to increase the temperature? So you can look into this relation. When the temperature increases, number of collision increases between the inter molecules or inter electrons. So these electrons, when collision increases, the relaxation time between the collision going to be decreases, because continuously it's going to be collide means definitely relaxation time decreases. You can observe that how relaxation time is proportional. If the relaxation time decreases, T value decreases, R value increases. Yes, increases. So that's why when temperature increases, the intermolecular collision, number of collision increases, the relaxation time decreases. So that's why resistance increases. To represent that one within quotient of resistivity, so we supposed to use first PUC concept in thermal conductivity, where we are going to linear expansion, areal expansion, volume expansion, like that. When there is an temperature dependent of resistance, alpha is a quotient of resistance, where it's a difference between the resistance offered by two temperature and resistant at 0 degrees Celsius with the multiplication of that temperature. So or you can represent this one in terms of same multiplication with the two different temperature. It's an absolute zero temperature, 0 Kelvin temperature. It's in the case of two different temperatures. So later on, I'm going to solve some of the problems on this one. You'll come across to know about that, how it could be, give you an idea regarding how temperature going to be changes. Okay, let it be go for then another one concept, very beautiful concept that you very well known that. So you know that shortcut to remember this color coding. Do you know the shortcut to remember color coding? Hello, students. Is it
Yes,
audible? Yes.
Yes, sir.
So what is the shortcut that you remember?
it's a sentence, a lengthy sentence.
It's a BB Roy, Great Britain goes to Bombay via Gate.
Yes, that only, sir.
Yes, okay. Or otherwise, BP Roy, Great Britain has very good wife. Like that, you can remember that one. So where here you can observe that there will be a concept called as a four band system, where first band represents the first digit, second band represents the second digit, and the third band represents the 10 power of that resistance, 10 power of that one, and last one band represents the tolerance. So that could be gold, silver, or no color, means that will be 5%, 10%, and 20%. Sometimes there will be asking a questions like that. You may not remember that one. How it could be asked is very simple. When you are going to ask for 0.28, how you are going to write 0.28 plus or minus 10%. What could be the color coding? Can you?
Sir, black.
Sorry?
Sir, black, sir.
Black. Then?
Red.
Red. Then?
Gray.
Red. Then?
Gray, sir. Gray.
Gray. See, it is, I told you that 0 point. Then see, it could be not tell you regarding this one, because the another two bands are there. Apart from this, BB Roy, Great Britain has a very good wife. So there will be another two bands are there, which is not also represented in the slide. So they are, for gold, its value is 10 to the power of -1. And for silver, its value is 10 to the power of -2. Okay, that means this value could be written as 28 into 10 power -2. Can you write it as 10 to the power of -2?
Yes, sir.
Plus or minus 10%. That means 22 means you got 2 is red, and 8 means you got 8 is which color? 8 is
Gray.
gray. So that's why this value becomes red, gray, and 10 to the power of -2 is there. So that's why it comes silver, and 10% is there. So that's why again it comes silver. Are you getting?
Yes, sir.
Yes, sir.
Are you getting? If they are asked in less than 1 ohm, then you need to convert in powers. So it could be minus, it coming for gold, it could be 1 10 to the power of -1, and for silver it could be value of 10 to the power of -2. Okay. So it is a question which is in a exemplar problem. You can look into that one. Okay. So we'll see how this could be for this one example. Here, B, it's a brown, so it looks like brown, violet, and black. So what could be the value for brown? 1.
1, sir.
For violet, 7. And for black, it is a value for black is 10 to the power of 0. What is the value of 10 to the power of 0? 10 to the power of 0. Anybody? Anybody? What is the value of 10 to the power of 0? Its value is 1. 1. Its value is 1. Okay, fine. So that's why its value will be 17 plus or minus, because of gold is there here, 5%. So this is what the another one. Can you tell me for this one? GRB silver. Green, red, blue, silver. Fast.
52 into 10 to the power 6.
52 into 10 to the power 6 plus or minus 10%. Okay. So let's try for this one. Do it fast because only 3 bands are there. 4th band is not there. Brown, violet, black.
17.
17 into 10 power 0.
10 power 0 plus or minus? Tolerance 20%. Because there is no color, no band is there means you need to represent 20%. Clear? The 4th band is absent means you need to consider that one is no color band. So that's why you need to consider 20%. Are you getting?
Yes, sir.
Okay.
Yes, sir.
So there is a very well-known shortcut method. B.B. Roy of Great Britain has a very good 5, and she love gold and silver. So that like that we are going to consider. So you can easily remember by putting the value 0 to 9, 0, 1, 1, sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For capital letter only, you need to write the numbers. Okay. Okay.
Yes, sir.
Okay. Now, another type of color coding of resistance are there. It could be for a general purpose. I told you. You can see like this type of dots are there. Only single band colors are there. So it could be represented in different values where dots are represented over there, so that you can easily identify the resistance. It could be like this: so blue dot, red ends, and yellow body. So like that, and golden strip. So it could be also represented as Y, R, B. So the color which is filled will be yellow, and ends will be R, second digit, and third digit will be blue and golden. So the value is similarly you can find out using that same method, using that same table. B.B. Roy Great Britain, that same table, you can find out the value of resistance. Okay. Now coming to the how these resistance are connected for our application purpose. That you know that it could be connected in series and also parallel combination. What happens when this when you are going to connect resistance in series? Is the resistance going to increases or decreases? Is that resistance goes to increases or decreases? Can anybody? Resistance goes as increases or decreases? The resistance value goes on increases, as you are going to observe that the resistance goes on increases, because as your resistance goes on add up when you are going to connect it in series. If you are going to connect these resistors in parallel, the resistance goes on decreases. So that's why the effective resistance or equivalent resistance is greater than the greatest value. If in case 1, 2, 3 is there, means the effective resistance will be 1, 2, 3 is 6 value, which is greater than the greater value. If you are going to consider for the same resistors in the parallel combination, that means 1 by 1 plus 1 by 2 plus 1 by 3. If you're going to simplify, it could be smaller than the smaller value, that is 1. Clear? Clear? Clear,
Yes,
students? Okay.
Yes, sir.
So, coming to the source of EMF, I told you in the last class that is electromotive force. What is the source for electromotive force, and what is the difference between electromotive force and potential difference? I told you when a circuit is open, then only you can consider that there will be a electromotive force in a cell. When you're going to consider potential difference, it could be any part of the circuit where what could be the current flowing and what is the resistance which is offering over there. The ratio of that one that gives you potential. The multiplication of resistance and current gives you the potential difference. V is equal to IR. So it is independent of resistance of the circuit, which one? EMF. So the resistance of the circuit doesn't affect because EMF is in open circuit. So that's why circuit resistance will not affect. But potential difference depends on the circuit. So what would be the circuit resistance on the basis of the potential difference goes to changes. If the resistance goes on increases, current goes on decreases, then the value is going to be altered. Clear? Similarly, internal resistance, that we already know that it's a factor of affecting internal resistance of the cell due to the internal opposition in between the electrodes of the cell. So where you're going to observe, because of why it appears internal resistance means it's because of there will be a lot of difference in electrodes distance, or it could be a chemical reactions going to be taking place in a larger time. So it depends on different factors, so that you can see here. And how it could be represented in electric circuit is small resistance R, which is series with this cell. Sometimes it could be represented on itself on the surface. Now, if I'm going to consider for an closed circuit, what could be the expression for what is the total current which is flowing through the circuit will be given by I is equal to E by R plus R, where R is the external resistance and small r is the internal resistance. Are you getting? R is the external resistance and small r is the internal resistance. Clear?
Yes, sir.
Okay. So now internal resistance, how it is going to be vary with respect to potential or the ratio of internal resistance and external potential difference. For that one, you can use this relation E is equal to V plus V, where V is the potential outside and small letter v will be the potential drop across the cell itself. So if I'm going to consider, the value will be IR is equal to, that is internal resistance R and current to the cell itself will be equal to E minus E, that is external EMF of the cell and minus external potential drop. The difference between these two gives you the product of I into R. So that's what a thing that you did in lab also, internal resistance of the cell, where we are going to connect first a cell without a resistor, then you are going to add a resistor. By using that one, you can find out the internal resistance of the cell. So to find out the internal resistance of the cell, there is a formula E by V minus 1 into R, where R is the external resistance, E is the EMF of the cell, V is the external potential difference, and minus 1 is the constant number. Okay, so here is a demonstration of internal resistance of the cell by a voltmeter method, where I told you that one did in your lab also. So we just look into that one because it could be asked in that case study type of questions. Okay. Okay, students. It's an open circuit where the circuit is not closed. So that's why the voltage that you are going to measure in the voltmeter is EMF of the cell. When circuit is closed, when the circuit is closed, you are going to measure the potential difference between the terminals. Okay?
Yes, sir.
Okay. Now coming to the cells which are connected in series and parallel. So for cells which are connected in series, it's quite easy to understand. But when you are going to connect it in parallel, it's quite complicated, because sometimes cells are connected in like parallel, sometimes they are connected in opposite poles. So that's why we need to connect cells in series combination by side. If they are connected and joined together and to an external resistance, this type of combination will be called as series combination. Are you getting?
Yes, sir.
Yes, sir.
Okay. So when you are going to observe that when they are in series combination, what could be the current that is flowing, and what could be the effective EMF, and what could be the effective resistance offered by this cell? To understand this one, we need to use a simple relation. Using that one also you can find out. So that is total EMF of the batteries, because here I consider E. All are same EMF. So that's why I'm going to consider N into A. If the EMF is different, say for example, it's 2 volts, it's 3 volts, it's 5 volts. So what could be the net EMF? It's going to add up or subtracted?
Add up.
Add up. It's going to be add up. If all are equal, then N into E it comes. And what about the resistance? Because these are resistance also connected in series. So that's why the internal resistance will be N into R. Clear?
Yes, sir.
Now, if I'm going to consider total resistance in the circuit, means one is internal resistance and another one is external resistance. Internal resistance is NR and external resistance is R. So total resistance is NR plus R. Is it? Is it, student?
Yes, sir.
Okay.
Yes, sir.
Now you can see that the expression for current is I is equal to N into E, that is E by R plus R. What could be the N? N here is number of cells connected in series. So NE by NR plus R. So effective EMF is NR, effective internal resistance is small NR. Like the current which is flows through the conductor will be NE by NR plus R. So there will be a condition when the current is maximum. So when internal resistance is equal to external resistance, then the circuit has maximum current. Remember, when the internal resistance is equal to NR equal to external resistance, then current in the circuit is maximum. Clear? Clear,
Yes,
students?
sir.
Okay. So now coming to the parallel combination, where you are going to understand how they are going to connect. So here is a complete circuit I have given. So 3 cells are connected side by side, and all the positive terminals are joined to the one end, and all the negative terminals are joined to the another end. So now, if you are going to consider EMF, what a thing happens? So here the EMF 2 volts is there, here is also 2 volts, here is also 2 volts. The potential difference between if the circuit is open, then the potential difference between these two terminals will be remain same. So that's why when we are going to consider the cell which are connected in parallel, we are going to consider only one EMF. That is, if 2 volts is there, 2 volts is there, 2 volts is there, you need to consider 2 volts. Suppose, sir, one cell is 4 volt and remaining 2, then you need to consider maximum EMF cell. Clear? Clear, students? You need to consider maximum EMF cells. Sometimes you may used in a remote car or some gadgets that you are going to use. There one cell may be weak, another one cell may be strong. Then also that's going to be work on the basis of the potential which is having a maximum potential which is having the another cell. And the internal resistance, what happens? See, when the cells are connected in parallel, resistance are also connected in parallel. Therefore, effective resistance of internal resistance becomes reduced by n times. If you are going to connect 3 resistors, it could be reduced by 3 times. If you are going to connect 4 resistors, it could be reduced by 4. Clear?
Yes, sir.
Okay. Now you can see what is the total resistance in the circuit is external resistance R and internal resistance N R by N. So therefore, the total resistance is R by N. Therefore, current in the circuit is, as we already know about in the series combination, is I is equal to NE by R. N small letter r is there. Here you can observe that its value is reformed because R by N is there. If you are going to take an LCM, what it becomes? N capital R plus R, a denominator N goes to numerator. So that's why it becomes NE, N capital R plus small r. Clear? Clear, student? Are you getting? Huh?
Yes, sir.
Here also, remember, here also, when current is maximum means internal resistance is equal to external resistance. Then only the current will be maximum. Clear?
Yes, sir.
You can see that R, if it is very much smaller than R, then E will be NE by R. So NE by R, this quantity will be effect. If R by N is very much smaller than R, you can neglect this one, and also you can write it as NE by NR, that is NN cancel E by R. Okay, so this is what a thing which is related to first part of the current electricity chapter. So if you are moving to the second part of the current electricity chapter, where you are going to understand Kirchhoff's law. So what is the Kirchhoff's law says? And why we need to understand Kirchhoff's law? See, when you are going for higher studies, in engineering or in any IITs or any electronic branch, then we are going to understand these two basic laws. After this, there will be different laws are there. Norton theorem, maximum power transformation theorem, Thevenin's theorem, like that. There will be a different theorems that's going to be considered because the complexity of the network increases. As you know that when the circuits are very simple, using Ohm's law, you can easily calculate. But when there is a short circuiting in a circuit, then how you're going to solve. So here, if you are interested, I just give you a simple one problem. Can you tell me that if one resistor, so this is R1 resistor and R2 resistor, and this could be R3 resistor. Here, three resistors are there. They are connected like this. And one wire is connected like this from here to here. And another one wire is connected from here to here. So are you getting? This one is R1 and this one is R2 and this one is R3. Can you tell me that what is the effective resistance of this circuit?
All three are in parallel.
Yes, all three are in parallel. How it could be parallel? That you need to understand. You just mention this junction by ABC notation. Then you can observe that A, B, C, and D. You can solve this one. A to B one resistor is there, and B to C one resistance is there. Again, C to A, there will be a short circuit. If in case, if I'm going to use another one resistance here another one resistance is added. If in case there, here and here, what happens? See, it looks like an Wheatstone split, because if you're going to stretch this one terminal and this one's terminal, it looks like this one is a P, this one is Q, and this one is R, and this one is S. So like that, it looks like a Wheatstone bridge. You may remember this one. Are you getting?
Yes, sir.
Okay. So when you are going to observe a complex circuits, then we need to use this Kirchhoff's law. So, and Kirchhoff's law applications that you did in practicals also. So that's what I'm going to discuss here, because it could be useful for your case study type of questions and also for 5 marks questions. Okay, let's go to the Kirchhoff laws. What it says. The first law is current law, or that we also called as junction rule, where the incoming current is equal to outgoing current at a junction. You can observe here blue lines I1 and I4, which are incoming current. I2, I3, and I5 are in outgoing current. So therefore, the total incoming current and outgoing current at a junction is 0, because one is positive, another one is negative. What could be coming will be equal to what is the current that is going outside. So that's why there is no charges deposited at the point of junction. Clear?
Yes,
Clear,
sir.
students? Okay. So here, sign convention that we used, however you can use, if incoming is taken as positive and outgoing is taken as negative, or maybe outgoing is taken as positive and incoming is taken as negative, doesn't alters. We just need to consider one is one, another one is opposite of that one. Clear? Clear, student?
Yes,
And as I told you that there is no charge accumulation at the junction. Remember, many of time MCQ questions may be asking like, what could be the charge accumulated at this junction? Because it's not a capacitor to store the charges. It's a point, it's a junction, it's a conductor, conducting points. So that's just it transfers the incoming current to the another conductor only. There is no storage of charges. If there is difference in this current, definitely there should be a charges which is stored here. Okay. So now coming to the Kirchhoff's second law, that is voltage law or loop rules, where you are going to understand using a simple loop. So there we consider a 2 EMF cells and 2 loops which are formed by the resistors R1, R2, and R3. Here you can see that there will be a ABC. A is one loop, and ACDA is another one loop. So here, what could be the current that is traveling?
Sir,
Yes?
are you writing on the screen, sir?
No, I'm just showing in animations.
Sir,
Screen share is
but
not
nothing is
visible.
visible, sir.
Nothing is
Yes,
visible.
screen share is.
Nothing is visible. Now?
Yes, sir. Now we can.
Yes, sir. Now visible, sir.
So that means up to this much you doesn't know about that. Okay. Now it is visible, no?
Yes,
Yes,
sir.
sir. Now
Visible, sir.
Okay, fine. So because I found difficulty in writing that in pad, so that's why I use animations so that it could be easier for you to understand. Okay, here I have given an explanation regarding Kirchhoff voltage law. So there will be a resistor R1, R2, R3, and E1 and E2 are the two cells which are forming a two loops, ABC one loop and ACD another one loop. Now you can see that there will be a current which is flows from the two cells I1 and this is I2. Now if two current coming at the junction A, what I think happens? The current should flows through the R2 as from A to C or C to A.
A to C, sir.
A to C. So that's why I will consider here as I1 plus I2. Now, when it comes to the junction C, it's going to be split in two ways because here is also negative terminals is there. Here is also negative terminals is there. So that's why it's going to be split into I2 and here I1. So the I1 current flows in the mesh ABCA and I2 current will flows through a mesh ADCA. Is it?
Yes, sir.
Yes, sir.
Okay. So if I'm going to consider the first loop ABCA, so how you can write the Kirchhoff loop rule as, because the direction I am going to consider is clockwise direction, but the cell is in opposite direction. So that's why I'm considering minus E1 plus I1 into R1, I1 into R1. So you can see this one, I1 into R1, which is opposite of that one, plus I1 plus I2, I1 plus I2 into R2. So all are considered to be opposite direction. Clear?
Yes, sir.
Similarly, when you are going to consider for an loop ACD loop. So here also we need to consider the loop direction I1 plus I2 into R2, the negative, minus I2 and I3 are negative, and E2 will be considered as in the same direction, positive. So if you are going to solve this one, you can get the value. Here the sign convention is there. EMF is taken as negative when they transfer from positive to negative. See, observe here, the current is moving from positive to negative. So that's why you need taking negative here. When EMF is moving from negative to positive, so the direction which I'm going to consider here is negative to positive. So that's why I need to consider EMF as a positive. Clear? In the first loop, is it visible? Positive to negative. So you can see light current will be flowing. The direction which I am going to consider is positive to negative. When you are going to consider in the second case, the direction which is considered is negative to positive. So that's why in the next second case, we need to consider positive. In the first place, the EMF will be considered as negative. Okay.
Yes, sir.
Okay.
Yes, sir.
So we'll go to the next one. That is the application of this Wheatstone application of this Kirchhoff law. So that is Wheatstone bridge. So what is Wheatstone bridge? It's a 4 resistor which are connected rectangularly and a galvanometer which is short circuited in between the two terminals, and remaining 2 terminals the external EMF is applied. So if I am going to consider at a junction, the current which is flows through the cell will be divided into 2 parts. One is I1, another one is I minus I1. The current I is coming, so that's why I minus I1. Now when you are going to enter to the junction B. So there will be a current that's going to split again two part. One is Ig, another one is I1 minus Ig. Similarly, this current enters to the point where I1 minus Ig is there, and I1 minus I1 is there, and Ig is incoming. So that's where you are going to get I minus I1 plus Ig. If I'm going to add these things at the junction C, if I'm going to consider, you can look into that. I1 minus Ig is there. Here, minus 1 plus Ig is there. So that's why these two cancel. So what the thing that remains is I, the current that is remaining here. So that flows through the loop. Clear?
Yes, sir.
Okay. So applying
Yes, sir.
Kirchhoff. Now, if you're going to apply Kirchhoff voltage law to the first mesh ABDA, there is no EMF. So that's why we are going to consider the EMF is 0 here. Now, the direction of current that you are going to consider I1 minus I1P minus I1G, and when I'm going to consider the opposite direction will be positive, plus I minus I1 into R, that is equal to 0. Or you can consider as I1P, that means plus I1P plus IgG minus I1 minus I minus I1 R. Like that also you can consider. Clear?
Yes, sir. Clear, sir.
Okay. Now coming to the second loop, when you're going to look into the BCDB loop, there also you can have an expression like minus I1 minus Ig minus of I1 minus Ig into Q resistance, plus there is a resistance here I minus I1 plus Ig into S resistance here, and Ig plus G is equal to 0. The direction which we consider opposite sides will be considered as negatives, and the same direction will be considered as positive. So here you are going to solve this one. You will get the expression, and when you are going to put the value, that means when the circuit is balanced, the flow of current in this direction and this direction are same, means then the flow of charges through the galvanometer is 0, because current is always flows through the lesser resistance path. It is not going to be move in a higher resistance path. So if resistance is more and the resistor easily flow from these two, means the circuit is balanced, means Ig will be 0. Then by manipulating these things, that means if you're going to substitute the values, Ig value is 0, and if you're going to divide above equations, we'll get an expression for balanced condition is P by Q is equal to R by S. Maybe it could be explained in the form of R1, R2, R3, R4. Is it? Is it for you? It could be explained in the form of R1, R2, R3, R4. Yes.
Yes,
Okay.
sir. Yes, sir.
Yes. Don't worry about that one. But keep in one thing in your mind: the resistance should be connected in zigzag manner. Remember, it should be connected in zigzag manner. Clear? P, Q, R, R, S. It should not like the cyclic order. P, Q, R, S. Not like this. Clear?
Clear, sir.
If you are going to consider in a R, if it is R1, if it is R2, then where is the R3? It should be R3. Clear? It should be R4. Clear?
Yes, sir.
Clear, sir.
Okay. Now, go to the next concept, meter bits. So maybe in the practical also you have one experiment that where you are going to find out the unknown resistance. What is the use of meter bits is you are going to understand, you are going to find out the unknown resistance. This is a modified form of Wheatstone bits where you have two L-shaped metal strip provided by a middle strip, and there will be a left gap and a right gap which is formed, and a 1 meter wide, which later on going to be divided into equal parts on the basis of balancing. And left gap, there will be a standard resistance box will be used, and in the right gap, unknown resistance will be added. Clear? Are you visualizing?
Yes, sir.
Okay, fine. Now when you're going to connect a galvanometer between the point, so this point is A means, and this one is B means, this is C and this is D. So where the galvanometer is connected, and somewhere the galvanometer shows zero deflection. So where when the distance of A to B is L and sorry, A to J is L and J to B will be 100 minus L. So resistance directly proportional to length, that you very well know. So that's why on the basis of that one, R in divided by X, that is P by Q, or R1 by R2 will be equal to R, P by Q is equal to R by S. Like that, you can consider resistance of A to J is due to the length 1 centimeter or L centimeter, and J to B is the resistance which is offered 100 minus L centimeter. So that's why if you are going to modify this expression, so you are going to get an expression as R by X is equal to 1 by 100 minus, sorry, L by 100 minus L. So if you are modifying this one for unknown resistance X, the expression becomes X is equal to R into 100 minus L by L. So it is quite easier one. So same type, if they are giving, and for example, can you tell me if this resistance is 5, standard resistance is 5 ohm. I'm writing here, you just calculated its resistance is, standard resistance is 5 ohm, and this one is 3 centimeter. Can you tell me what could be the value? Sorry, 30 centimeter, not 3 centimeter, 30 centimeter. So what could be the value of X? Can anybody? Can you calculate? Can you calculate? This is 5 ohms and this is 30 ohms. And what could be this one? 100 minus L. If this is 30, if this is 70, students, are you able to listen? Hello, students, are you able to listen?
11.3, sir.
11.3. Good, good. See, this is 5. There is the standard resistance value 5 multiplied by 70 by 30. So that comes 0, 0 cancel. 7 5s. What's the value of 7 5s?
35, sir.
35 divided by 3. 35 by 3 divided by 3 is approximately 11 point something. So its value will be 11 point. Like that, you can calculate unknown resistance using meter bits. Clear?
Yes, sir.
Okay. Coming to the another one concept, it's quite a little bit confusing for you regarding potentiometer. There will be a conflict survey. How the potentiometer showing the deflection in a meter. So it is also working on the basis of Wheatstone bridge, but the thing is, it is modified form of Wheatstone bridge. So it has some of the potentiometer has around 4 meters or 400 centimeters. In some of the potentiometer has 100 centimeter wire is there. Here you can look into this one. From A to B, there will be a continuous zigzag arrangement of resistor wire. So that is 400 centimeter is there. And if we are going to connect this one with an external EMF and an rheostat, why we are going to use the rheostat means we need to vary for different reading. While taking for different reading, we are going to vary this one. So if I'm going to measure the value from A to a junction J, the potential will be same. See, the potential will be same means the potential drop across this length and remaining part will be same. So then only you will observe that the current which is flows through the complete circuit from it start from here, flows like this, and like this, like this, like this. So for a given cell, you can observe this for an E, you'll observe that there will be a balancing point at J, something A to J. So if I'm going to replace this one with another one. So where you are going to use comparison of EMF of cell that tells you regarding how voltage depend on length. Here V is equal to IR, where R is represented as rho into L by A. Rho is density, resistivity, not density, resistivity. I is current, or L is length of the conductor, and A is. Now you can use this relation to relate how potential and length are dependent. They are directly proportional. It is L, not I. It is L. Clear, student?
Yes, sir.
Yes, sir.
Okay. Okay. So now you can see that voltage and length are directly proportional. If the voltage is increased, length also going to be changes. To understand this one, comparison of EMFs of cells is used. Same type of circuit is used, but here the EMF that used is one EMF. Let it that will be a E1 EMF, where you are going to connect seriously with the same circuit, where you are going to consider another one. So there, see, you can observe that the J point initially lies between 0 to 100. Now it shifted to 100 to 200 gap. Is it?
Yes, sir.
So now if I'm going to consider another one cell which is connected in parallel to that one, and if I'm going to remove this key and connect that one to this one cell, because this one is removed, so what I think happens is you can see that the EMF that is going to be changes. So that's going to be changes to J2 position. So that's going to be changes. So that's why E1 and E2 ratio depends on what? L1 and L2 length, the balancing A to J1, A to J2, from A to J2. So the length will be L1 and L2. Sir, if the why J2 value decreases? Because the E2 cell, which we consider with the lesser EMF. If the E2 cell is having a larger EMF than E1, then this J2 will be somewhere between 200 to 300. Are you getting, student?
Yes, sir.
Okay. So like that, you can compare the unknown EMF of the cells. If the anyone cell is not known the EMF, exact EMF, you can using this experimental setup, you can find out the EMF of this cell. Are you getting?
Yes.
Okay.
Yes, sir.
Fine. So this is what the concept which is related to current electricity chapter. So is there any doubts related to this one?
No.
No. If you doesn't have a doubts, means then I'm going to basically fix for two major chapter for problematic discussion. One is your communication chapter, problematic discussion. Another one is your optics, because they are your point difficulties. So that's why. So I kept this one separately. So we'll discuss later. So I think so you doesn't have any problem or any issue regarding current electricity.
So in numerical, we just need to find the error percentage. What is that formula?
Sorry, can you once again repeat?
Numericals, we get the question like also find the error percentage along with terminal voltage.
Error?
Error percentage.
Error percentage, which is related to first UC concept. Errors. Can you remember what is error? What is error? How we are going to add up error? How we are going to subtract error? Error percentage. So there you are having a relation Z is equal to A plus B, means if two numbers are added up, how that's going to be? Can you remember? So there we come across to know about that what could be the percentage of error. Can you remember the formulas which are related to errors? Addition formula, subtraction formula.
Yes, a little bit. Otherwise, then you can just pick up.
Sorry, I doesn't get it. Is it audible?
Yes, sir. Yes.
Yes, tell me that.
So once you can just revise it, then you At present, it's not repeating it. Once we start with the writing, we will remember.
Okay, fine. I'll just use 1 second. See, so there will be they are providing a resistance like R is equal to some value to plus R minus 0.01. One resistance is there. If they are going to connect another one resistance in series, this is will be considered as R1. And in another case, R2 resistance is there, which is 3 plus R minus 0.02 is there. Means what it actually represents is 0.01 and 0.02 are students. Are you able to observe the display?
Yes, sir.
Okay. So if you are going to observe like that, if they are connected in series combination,
I will take that.
yes. If they are connected in series combination means what could be the effective resistance? That you can easily tell us that 2 plus 3, 2 plus 3, it's 5. But what could be the percentage of error? How to understand this one? To understand this one, we need to know about the formula. How if two resistors, any two errors are added, then the error in resultant will be delta A plus delta B. Error in A and error in B, that's going to be added up. In this case, it could be plus or minus. The percentage of changes in could be represented as divided by Z divided by A divided by B into 100. You may remember this formula, into 100. So this is what percentage of error in B, percentage of error in A, and this is what the resultant percentage of error. So here the percentage of error that they are that doesn't given, you can consider the R1 percentage of error is changing the resistance R1 to the original resistance R1 into 100. So that value will be 0.1 divided by the two value of resistance is 2 into 100. So what could be this value? So 0.1 multiplied by 100 is
10.
10 divided by 2 is
5.
10 divided by 2 is 5.
5.
So you can consider the percentage of error in R1 resistance is 5.
Okay.
Okay. Similarly, when you are going to consider for R2, percentage of error is 0.02 divided by 3 multiplied by 100.
Yes. Okay.
So it could be 2 divided by 3.
2 by 3.
2 by 3. Its value of percentage of error will be
0.
approximately 0.
6.
0.
6.
Sorry, it will be disturbing. 0.
6.
6. Is it? 6.
Yes,
It's coming.
0.6.
6. It's coming. 0.666. So this could be the percentage of error. Now, what could be the percentage of error in series combination? So then you can identify, you need to find out these two summation. That means 5% plus 0.66. So that percentage of error will be 5.66, or you can consider 67 because 6666 reappears. So that's why you can consider this one as a 5.67. So the effective resistance is this much, and the percentage of error is effectively percentage of error comes plus or minus 0.67. Clear?
Yes. Yes. Thank you.
Okay. Okay, I think so. My slide is disappeared.
Yes, sir.
Yes, sir.
Yes, 1 second. I'm just going to share another one slide. Yes, now it is visible.
Yes, sir.
Yes, sir.
So this is an another big chapter concept, that is ray optics. So here you just look into that, how I am created that one in animations, because last class we discussed regarding lens makers formula, lens formula, image formations, how the convex lens, concave lens are going to be form the images, what could be the lens makers formula, and how the convex, sorry, microscope are going to be form images, and what could be the expression for magnifications. So that I'm going to discuss here in the this one slides. So do you need a break, or I'll give a break at 6 o'clock?
Yes, sir.
Sorry.
Sir, you can give at 6 o'clock.
Okay, fine. So I'll just complete this one slide. So later on we'll discuss problems on this one, so that it could be easier for you. So the concept that comes when you look into the chapter ray optics is huge. Concepts are there, which is based on reflection, diffraction, and many concepts are there. So and finally you are going to understand linear magnification and then angular magnification. So let us start with conceptually. First concept, what is reflection? So what is meant by reflection? Oh, first I started refraction. Okay, fine, not an issue. Refraction. What is refraction? When light enters from one medium to another medium, so there will be a bending phenomena occurs. So that phenomena which we called as refraction. So medium is quite different when it light enter from one medium to another medium. So there we are differs on the basis of rarer medium and denser medium. So what is rarer medium? The light which is moving faster than the other medium. So that we call as rarer medium. The light which is moving slower, the speed will be reduced when it enter from a rarer medium. So that we call as denser medium. Is that glass is a denser medium?
Yes, sir.
What about if the glass is compared with a diamond? Glass compared with the diamond.
Sir, can you repeat the question, sir?
The question is simple. If the rarer medium is glass, if the rarer medium is glass, if the rarer medium is glass, and denser medium is, if I'm going to consider diamond. Now tell me that which one is denser and which one is rarer?
Glass is denser, sir. Diamond is rarer.
No. See,
The
remember,
diamond is more denser.
diamond is thicker than glass. Is that glass is broken by diamond, or diamond is broken by glass? Is it diamond is broken by glass? No, glass can be broken by diamond. Is it?
Yes, sir.
See, you can consider when you are going to consider for a vacuum. Vacuum will be considered as a very rarer medium. The density will be lesser. If I'm going to consider air, what is the difference in air and vacuum? So in air, there will be a possibilities of existence of oxygen, nitrogen. Is it? When it comes to vacuum, there is no air particles. Clear? You should understand, in vacuum, the density is very lesser compared to air. If you are compared with the water, a little bit density is more in water. When you are going to compare with the glass, this is quite little bit denser than the water. And when you're going to compare with the diamond, the density goes on increases. Clear? Clear, students? When we are going to consider the rarer and denser medium, we need to compare with the another medium. So if I'm going to compare water with air, then water is a denser medium. Is it?
Yes, sir.
If I'm going to compare water with the diamond, then sorry, one second. Sorry. If you're going to compare with the water with the diamond, what thing happens is a diamond is a denser and water becomes the rarer medium. Are you getting the difference between denser and rarer?
Yes, sir.
Okay. Okay. Now let us go for the next concept, that laws of refraction. That you know that what is the law? First law of refraction says that incident light ray, and refracted light ray, and the normal which is drawn will lie in same plane. So all are lying in a same plane. So it is not like that this one incident light ray come in this direction and it may come out of the plane. It should not come out of the plane. All incident light ray and normal and refracted light rays lies in a same plane. When you're going to consider the second law, for reflection, if I'm going to consider the angle of incidence and angle of reflection, is that they are same for reflection, because light entering from one medium and reflects back to the same medium. So in this case, the angle of incidence should be equal to angle of reflection. Is it?
Yes, sir.
So in refraction, there will be a relation called as sine of the angle of incidence to the sine of the angle of refraction. So this is what the sine of the angle of incidence to the sine of the angle of refraction. So that could be is equal to a proportionality constant mu that you are going to use, that mu r n they are going to use, that will be called as the refractive index of the medium. Refractive index of the medium. So this refractive index will be gives an idea how refractive index gives an idea how the velocity of light is going to be changing. Velocity of light going to be changing when from one medium to another medium. Okay, fine. Now the refractive index, refractive index, how we are going to study. So there are two ways. One is refractive index of air and vacuum, that is considered to be 1. And when you're going to consider for a refractive index for a denser medium, it's going to be vary with speed of or velocity of the light. So as the velocity changes, more changes will be there, more will be the refractive index. For example, if I'm going to consider for an what could be the refractive index for air and vacuum refractive index, the ratio of air vacuum ratio. So there you're going to observe the value is very, very small. There is one, there is a small change, 1.0023 or 26, something like that you are going to get. So this value, which is quite approximately equal to 1, we consider. So that's why, so when you're going to consider refractive index of air and refractive index of vacuum, then we are going to consider its value is 1. When we are going to consider for the refractive index of water with respect to air, if you are going to consider, this value is 1.33. If refractive index of glass, if you are going to consider with respect to air, its value is 1.5. There will be a difference. Its value may vary from 1.5 to 1.6. It depends on which type of glass. Crown glass is there, flint glass is there, then borosilicate glass is there. So different type of glass will possess different values of refractive index. Similarly, refractive index of diamond. Remember this one, it could be asked in multiple choice questions. Its value is 2.4. Remember. So for air, For air, it could be 1.0026, for water 1.33, and for glass 1.5, and for diamond is 2.4. Are you getting? Are you getting, student?
Yes, sir.
Here, where you are going
Yes,
to
sir.
consider, it is absolute refractive index. You should understand what is absolute refractive index is. Refractive index of a medium will be compared with the air or vacuum. So that's what we call as absolute refractive index. Relative refractive index means if I'm going to consider the refractive index with respect to water, with respect to glass. If one layer is filled with water and another layer is filled with glass means, then what could be the refractive index between these two medium? These two medium is, then you need to consider the ratio of these two. So that is 1.5 divided by 1.33. If I'm going to consider diamond and glass, or if I'm going to consider diamond and water, then the value going to be changes. Clear? But you need to
Yes,
remember,
sir.
refractive index, absolute refractive index of water, glass, and diamond. The value is 1.33, 1.5, and 2.4. Clear? Clear, students?
Yes, sir.
Yes,
Clear,
sir.
sir.
Okay, fine. So another one property that shows by a light is principle of reversibility of light. What is reversibility means? If the light enter from rarer to denser medium in a one path, then it can be retraced in the same path. If I'm having a mirror in the middle, then definitely it's going to be retraced the same path. So then only the medium is perfectly all right. If there is a variation in this one means there will be a medium is not uniform. It is not a homogeneous medium. If it is a heterogeneous medium, it's going to be changes. But it's a homogeneous medium means that means if it is not filled with an impurities, then it's going to be retraced in its own path. So that's where we are going to observe absolute refractive index, how we are going to study. Next, another one concept that is also important for your competitive exams and also for your conceptual 3 marks, 5 marks questions, skill based question. Okay, if there are parallel slabs means if there are number of mediums which are there, where the light going to be reflects, or sorry, not refracts from the medium. That means when light enter from the rarer medium and goes to the denser medium and again goes to the rarer medium, it going to be changes its path. You can look here, you can observe here, actually the light should be passes through this direction, in this direction. Sorry. Okay, the light should be passes through this direction. From here you can consider it should passes like this, but thing is that going to be shifted by here when angle r, again that's going to be shifted, so it should flow like this, it should move like this, but the thing is it again shifted like this in this direction when it enter from denser to rarer. You'll observe that there will be a parallel separation between these two lines. So this is the direction of incident light radiations and this is the direction of emergent light radiation. So if I'm going to understand using the concept called as, you may know about that one, that is called as lateral shift. What is lateral shift? What is lateral shift? Very simple. It is a perpendicular separation between the incident light ray direction and the emergent light radiation that we call as lateral shift. And it could be measured using a relation. What could be the lateral shift? Y will be there. It is T sine of delta. What is delta is how much angle of refraction is there. Deviation is not refraction. Deviation is there. Delta to the R cos of R1. What is R1 means? It's an angle of refraction. So sine of delta by cos of refraction R1. So that gives you an expression, or you can modify that one as equation as I1 minus R1. That is deviation is represented as I1 minus R1. Is it visible, student?
Yes, sir.
Okay. So when it could be find out the parallel distance between the two emergent lines. So that distance will be called as lateral shift. It's going to be vary if I'm going to add another one medium. If I'm going to add another one medium here with another one values, then it's going to be vary. Again, it's coming with a different thickness, parallel separations. So in the competitive exams and also theory exams, this thickness is going to be divided into small pieces. There may be possibility of same refractive index or different type of refractive index. So then you can obtain an outcoming like this. That could be a parallel one. And what could be effective refractive index, they may be asking like this. Then you need to use this relation. We need to find out angle of incident and angle of refraction. Using that effective refractive index is found out by sine of I by sine of r. Clear?
Yes, sir.
Okay. 1 second, student. Hello, students. Are you there?
Yes, sir.
Yes, sir.
Okay, fine. So see that what I told you that if two mediums are there, so you can see this is a denser medium which is having a density B and denser medium which is having a density C, and A are two rarer mediums. How it's going to be changes? See, the refractive index of air is mu A, mu B, and mu C if I'm going to consider. So the light that's going to be bent when it enters from rarer to denser. When it enters from rarer to denser, it's going to be bent towards normal. You can see towards normal. Again, when it enters from denser to denser, observe here, this one density and this one density is larger. When it comes to C1, it is also having a more density. So that's why what thing happens is, see, the light should go in this direction. The light should go in this direction in the medium. But again, it's going to be bend means the density of the C medium will be larger. So that's why when you're going to observe that when the light enters from this medium, it reaches to this outward direction like this. Okay. So if I'm going to draw the incident and refracted ray for an Snell's law for an each set of mediums, then it's quite difficult to understand the total outcoming radiations. What is the lateral shift? For that one, individually you can compare the refractive index of the medium. For the first case, A to B, A this one and B this one. So here you can consider sine of I1 by sine of R1, and this R1 will be the incident angle for the second surface. Is it R1 is equal to I2? Can you understand this one? Why I write this one? If the two parallel lines are there, if this angle is theta, what about this one? It is also theta. So it's a high school problem. What we call that one as opposite angles. Opposite angles. Is it? Is it?
Yes, sir. Yes, sir.
Yes. Okay. So that's
Yes,
why when I'm going to consider here, second condition, sine of R1 to the sine of R2. This one is R2 I am considered here. Now R2 and this one R2 are opposite angles. Is it opposite angle? So that's why the refractive index of third one medium with the emergent medium, that could be R2 to R1. So now if I'm going to multiply all these things, A to B, B to C, and C to A. If I'm going to multiply all of this, we're going to get an refractive index 1. Or if you're going to modify this one, so then you're going to observe that A to B and B to C, A to B and B to C gives you a relation refractive index of A to C. That means reverse of this one. Or otherwise, if I'm going to find out the refractive index of B with respect to C, B with respect to C, then I need to divide refractive index of A with respect to C, A with respect to C, and refractive index of A with respect to B. If I'm going to divide these two and these two medium, then I'm going to get the refractive index between these two mediums. Are you getting? Are you getting, student?
Yes, sir.
Okay. So we'll see in the next one example where you're going to understand if the observation is at a perpendicular direction. That means when we are having a coin in a beaker, then you're going to observe one medium is denser and another one medium is rarer. When you're going to observe, this coin appear to be increased its distance or appear to be raised up. So when you look through a certain angle, it appears to be increased to an height. Or if you are going to look to an height normally, then also you will observe that this point O is appear to O dash. So therefore, so what we call this one as? This one as appearance shift. Appearance shift, because when you're going to observe in a rarer medium in the denser medium. So this is a well-known problem that the fish problem is there in your textbook also. So if the fishes are inside the water, it looks to certain angle only. It cannot look up or that one. So when you're looking the fishes from the upside, it appears to be at the raised up, but actually they are in the depth of R. So here you can find out that value using the same relation of a refractive index, or finally we have a simple relation when you are looking to a normal. So that relation is refractive index of the medium, these two medium. The refractive index of water with respect to A will be is equal to real depth to the apparent depth. What is real depth? What is real depth? Real depth is total thickness of the medium. Real depth is total thickness of the medium. What is apparent depth? Apparent depth is, it is from O dash to upside. O dash to upside. So where this height will be considered as apparent depth. Are you getting?
Yes, sir.
Okay. So if in case, if there are fluid is different, say for example, when the below water is there, above this one there will be a kerosene is there, above this one there will be a petrol is there, above this one there will be a diesel is there. Like that, if there are number of layers are there, then we are going to consider what is the total height, means total real depth. Total real depth means depth of the water, depth of the kerosene, depth of the petrol, like that we are going to consider. And apparent depth means you need to consider, you need to find out for each one. For example, if I am going to consider a medium which is filled with first water, then kerosene, then diesel, means the refractive index of the different mediums are different. Water has different refractive index, kerosene has different refractive index, diesel has different refractive index. We have real depth. Real depth is height of the medium. So apparent depth is nothing but using this relation only you can find out. If you are going to cross multiply this one, what you are going to get? Real depth by refractive index. So that gives you apparent depth of first medium, apparent depth of second medium, apparent depth of third medium. You can easily find out what could be the apparent depth for the different medium. So finally, total apparent depth, what could be the total apparent depth? That could be easily find out using the relation that a refractive index is equal to total real depth to the total apparent depth. So total real depth is depth of diesel, depth of kerosene, depth of water. Total apparent depth is what is the apparent depth of different values. So that gives you effective refractive index of the medium. Or if you doesn't know the what is the apparent depth or what is the real depth of the medium, it could be kerosene or diesel. That could also be find out using this relation. Clear? Clear, student?
Yes, sir.
And there is a lab, you have an experiment, you may remember that one. So there will be a microscope you are set up, and there will be a dot
Traveling
which is
microscope, yes, sir.
yes,
And
traveling
dot.
microscope. Dot that you are going to focus first. Then you are going to keep a slab of glass. Then you'll observe first. Initially, you observe this dot reading as R1 reading. Then when you are going to put a slab, then the traveling microscope move upward. Is it?
Yes, sir.
Then the dot appears like this here. So that's why here the reading you are going to consider R2.
Yes, sir.
Then you are putting some
Like
dust powder here,
lycopodium powder. Yes, sir.
yes, and then you are going to find out R3 distance. Now observe here, there also you find out the refractive index of glass, where we are going to use same relation, that is real depth by apparent depth. What is real depth here? According to this one, real depth is reading 1 to reading 3 is thickness of the medium, is it? So that's why it's R3 minus R1, is it? That's what we called as real depth. Similarly, R3 minus R2, that gives the distance from the apparent point and the upper surface. That is what apparent depth. Are you getting?
Yes, sir.
Okay, fine. So this is a concept which is related to your practicals also. Okay, fine. So if there are number of mediums are there, you can calculate using that one. Okay. Now coming to the another one concept, total internal reflection. Are you getting? Or it is becoming too faster?
No, sir. I'm getting.
Are you getting? Okay, fine. So now you'll going to understand what is meant by total internal reflection. So the phenomena, it's a very well known phenomena. When a light enter from denser medium to rarer medium, that you know that it's going to be bent away from the normal. Bend away from the normal. See, when light at the bottom, which emit normally, it refracts normally. It won't going to bend because the angle of incidence is 0. So that's why angle of refraction is also 0. When it is tilted through an angle, then you'll observe that the angle of incidence is this one. So angle of refraction is quite larger than the angle of incidence because it entering from a denser to rarer medium. So like that, if you are going to increase, so the angle of tilting going to be increases. The angle of incidence is lesser, angle of refraction is more. So at a particular position, you can observe that the angle of incidence where the angle of refraction is 90. So that angle we called as critical angle. Do you know about that critical angle? So what is critical angle means? It's a angle where the refract angle of incidence where light enter from denser to rarer medium, where refracting angle is 90 degree. If you are going to increase this angle of incidence more than critical angle, then light get reflected back to the same medium. So that phenomena which we called as total internal reflection phenomena. Are you getting?
Yes, sir.
So first you need to understand what are the conditions for total internal reflection. What are the conditions that required for total internal reflection is two conditions. One condition is light ray must enter from denser medium to rarer medium, and angle of incidence should be greater than critical angle. Then only the phenomena of total internal reflection appears. If not, the total internal reflection will not appears. Clear?
Yes, sir.
Yes, sir.
Okay. Now, so the there is a relation between critical angle and refractive index of the medium. So see, you'll observe that refractive index of glass with respect to air, we are not refractive index of glass with respect to refractive index of water, sorry, with refractive index of air with respect to glass. So here you can observe that light enters from glass to air, so that's why angle of incidence will be critical angle and angle of refraction will be 90 degree. So if I'm going to consider this one, so what could be the refractive index of glass with respect to air? It would be reciprocal of refractive index of glass, sorry, refractive index of air with respect to glass. So then, therefore, the value of refractive index of the medium will be sine of angle of incident, that is critical angle. So n is equal to 1 over sine c, or mu is equal to 1 by sine of critical angle IC. Okay. Is it okay? So these are all the conditions. Actually, what are the conditions that appears, and also some of the examples that you may know about that one. So there will be applications of total interreflection, how the mirage will be formed. Do you know about what is this mirage means?
Yes, sir.
What is mirage? Sorry. Is the screen is disappear?
Yes, sir.
So mirage is when we see something which appears to visible, but it's not the actual thing.
It's not the actual thing. So that we call it as optical illusion. Is it?
Yes, sir.
Optical illusion. How this optical illusion created in different
Excuse me, sir.
Yes.
So please explain total internal resistance again.
Total internal resistance or total interreflection?
So yes, sir. Sorry, sir.
Okay, fine. Let it be. No, not an issue. See, here I am going to write it and explain you. So when a light enter from, it's a denser medium. When it enter from denser medium, see, if it is normally coming out means definitely angle of incidence is 0, angle of refraction is also 0. Here, when it enter through an angle, obviously it should move like this. But when it is in a denser medium, angle of incidence is this one. Angle of refraction should be greater than the angle of incidence. So that's why at a particular angle of incidence for a given pair of medium, so that angle which we call as critical angle, the refracted angle will be 90 degrees. So this angle we call as critical angle. Clear?
Yes, sir. Thank you,
Okay.
sir.
So when it comes to the first case mirage, how this mirage will be formed? So to explain that one, you may see that in a road when you are moving in a summer regions, you maybe sit in the front seat of a bus, you can look into that one. The road is filled with water, but when you move towards that place, it again move away from that your vision. Is it?
Yes, sir.
Why
Yes,
it
sir.
happens? Why it happens? Simple. As you know that if I'm going to consider this is a road, in that during the summer days, what happens to the road? The road is hot. Completely road is hot. Is it? So because of hotness, the air above the road will be hot. You may see that flammable images on the surface of road. Is it?
Yes, sir.
When you are at the hill station in the summer region, when you are at the hill station, you feel cold in the hill station. Is it?
Yes, sir.
A reason
Yes,
here,
sir.
a reason behind this one is, as you move from the earth's surface to upward, the temperature goes on decreases because here the reflection is more. So that's why the surface, on the surface, what the air is there, this is hot air, and the upper surface is cold air. Now tell me that, is that cold air is denser or hot air is denser? Cold air is denser
The
or hot
cold
air?
air is
Yes.
the cold air.
Cold air is denser where the molecules are quite nearly arranged. When in the hot air, the molecules are arranged in a larger distance. So that's why when light enter from cold air to hot air at a particular angle of incidence, you can look into that one. Particular angle of incidence, at a particular angle of incidence, when light enters particular angle of incidence, you can observe that refracting angle will be, angle of incidence will be greater than critical angle. So that's why this light will reflect back. That means the image of sky, there will be a clouds in the sky. So these clouds are appear at the roads where you are going to observe that one in a bus, or if you are going to observe in the hot days. So this is what the mirage. How mirage will be formed? It's because of hot air and cold air. The reason the light enter from denser to rarer, where hot air is rarer medium, cold air is denser medium. So that's why it travels through a certain angle. If the angle which is greater than around this angle will be around 11 degrees, that means approximately, if you are going to consider 80 degrees at an angle of incidence 80 degrees, you can look into that, the total interreflection phenomena in case of mirage formation. Clear? Are you getting this concept?
Yes, sir.
Okay.
Yes, sir.
Okay. So now similarly, another one concept is there that we called as looming, total reflection in a prism, and optical fiber, and sparkling of diamond. Looming, no need to worry about that one. I'll tell you that one later. So total interreflection in a prism, how it is going to be happen. So I'll just give you an idea how the total interreflection takes place in a prism. So to understand this one in a prism, you need to consider a right angle base prism. I'm just considering right angle base prism. If the light enters in from this direction, I'm going to consider from this direction. Now tell me that from here, it is rarer medium, enters to the denser medium. What is the angle of incidence? 0. Here angle of incidence is 0.
Yes, sir.
So angle
Yes,
of refraction will be 0. Angle of refraction from this surface, if I'm going to consider this is ABC, from AB surface, it's going to be okay. Now when it reaches to the AC surface, this is what the angle of incidence. If the angle of incidence in glass is greater than 42 degrees, so remember how you can find out the critical angle is n is equal to 1 by sine of c. You can observe that the refractive index of glass is what? 1.5. Is it?
Yes, sir. 1.5.
1.5 is equal to sine of c. If I'm going to consider what is the value of sine of c means, its value is 1 by 1.5. 1 by 1.5 is 0.75. Is it 1 divided by 1.5 is 0.75?
Zero point 0.65.
0.65?
Yes, sir. 0.65.
Okay, 0.65. Okay, if you are going to find out the value of angle of cos of c using your logbook, what could be the value of c? Critical angle will be sine inverse of 0.65. So if you are going to solve this one, it's come up approximately around 28 degrees. Sorry, 42 degrees. Approximately around 42 degrees. So what is this critical angle? Now look into this one. If we have a minimum angle of 42, but here when it is a right angle base prism, the angle of incidence is 45 degree. Then what could be the reflection angle? This is also 45 degrees. So that's why light emerges out in this direction. It enters here and emerges out like this. So there will be a total internal reflection which causes 90-degree deflection of the light using the prism. Clear?
Yes, sir.
Okay. Similarly, if I'm going to consider another one case where light entering from a region from here. So you can consider, see, to this one face normally. Now observe here, what could be the angle of incidence? It could be 45 degrees. Is it? Again,
Yes, sir.
again it moved to a 45 degrees. Now you can look into this one is also 45 degrees because it is 90, and this is also angle of incidence and angle of refraction. So this will be angle 90. Now here also the angle of incidence is 45, and again it reflects back with a 45. See, so this is what the angle of incidence, it comes back to this surface and reflects to this surface. So if light incident on a hypotenuse face, here the adjacent faces, adjacent and opposite faces that you consider in the last case, when it will be an hypotenuse face, the light which is deviated by 180 degrees. In the last case, how much degree that you deflected? 90 degrees. Is it? In the last case. In this
Yes,
case,
sir.
you can observe 180 degree deflection will be takes place. Clear? So where these
Yes, sir.
prisms are used in submarines, you may know about that. In submarines, there will be a kaleidoscope is there. So you cannot every time come out from the submarine and you can watch what is the thing happening outside. So that's why what they are going to do is they are going to place a pipe-like structure like this, and in the downstairs there will be an observer who is observing that one. So you can observe here. Here what they are going to put is one prism here, one prism here like this, right angle base prism. Light if come in this direction, how much degree it going to deflect? 90 degrees, is it?
90 degrees, sir.
So 90 degrees means it moves like this. Again, what I'm going to do is here also I am going to put another one prism like this. Again, what I think happens, it's going to be deflected 90 degrees.
Sir,
so yes,
can we use mirrors, sir?
yes, mirror can be used, but the thing is mirror absorbs the radiations. Mirror absorbs the radiation. 100% reflection doesn't take place because mirror is coated with silver coating. Have you seen?
Yes, sir.
Yes, sir.
So that's why when light enters, only around 80% of the light will come out because there is a multiple reflection takes place from here, from here. If it is a small kaleidoscope that you are using for playing, no, there you can use this one. For submarines, like it could be a 10-meter long pipe. How it is could be possible to see? Is it?
Yes, sir. Yes,
So
sir.
for that purpose, they are going to use highly what we called as homogeneous. Homogeneous means highly homogeneous, same type of material should be there in a prism. That type of prisms are used in these kaleidoscopes. Clear?
Clear, sir.
Okay, so this is what another one application of
Yeah.
total interreflection. Now refraction through the prism, you came to know about that. Optical fiber cable. Before going to the optical fiber, I'll just go to the diamond. Now remember, again I just want to share you that what is the critical angle for diamond. That you know that I already told you that what is the refractive index of the diamond?
2.4, sir.
2.4. Remember that one. 2.4. Sin C is equal to 1 by 2.4. So then C is equal to what? It could be sine inverse of 1 divided by 2.4. If you are going to simplify this one, the critical angle is found to be 22 degrees around. Not exactly, I'm saying that one. If you want to find out, you just find out this one, 1 divided by 2.4. It value is 0. Something like 0.5 something like it comes. And if you're going to simplify this one with an using your logbook, you're going to get the value will be 22 degrees. Clear?
Yes, sir.
Okay. Now look into that, how the diamond will be shaped. Maximum diamond shapes, you know that. What is the shape of diamond? So as you've seen the diamond like this, is it? When
Yes,
light
sir.
when light enter from this end, see, the angle of incidence is less greater than 22 degrees. So that's why it's going to be total interreflected. Again, it's going to be total interreflected. Again, it's going to be total interreflected. So like this, the multiple reflection takes place in a diamond and the light coming out from inside other end. So that's why when the pure diamond is observed, maybe you may be seen in a diamond ornaments, when a small light is incident on it, it's going to be shining. Is it?
Yes, sir.
It's going to be sparkling. It's going to be sparkling. The sparkling effect is due to the multiple reflection, total interreflection of the light inside the diamond. It's because its critical angle is very small and the light goes to be totally interreflected for longer time, and when it is coming out, it loses some energy. If energy is loose means definitely if white light is coming incident on this surface, it may be blue color, it may be red color, or it may be violet color, depend on the wavelength of light which is coming out. Are you getting why diamond appears sparkling colors? It's because of total interreflection. Clear?
Yes, sir.
Okay. The last one concept that comes is optical fibers. What is optical fiber? What is meant by optical fiber? See, this is what you may see in your surrounding. There will be a decoration vase is there. There you can observe that a LED light is glowing here, and the fibers, white fibers like structure which are distributed like this. When here red color appears, here in the tip also red color appears. When here blue color appears, in the tip also blue color appears. So this is the part of the optical fiber cable. Optical fiber cable is not a 1 centimeter thicker cable. It's just a millimeter, it's less than millimeter, small cable, which has inner core and outer clouding. The word you should remember, inner core, outer clouding, and in the outer surface there will be a cover. Are you getting?
Yes, sir.
Inner core is made up of glass material. It's a kind of fiber material which density is larger, and outer clouding that you are going to observe, this one outer clouding that you are going to surround this core. So this clouding will has lesser density compared to core. So as the density is lesser, when light enter in this tube, when you're going to consider this could be a tube, when light enter, see this inner one is core, which is higher density. If the incident angle is greater than 45 degrees, what happens? It's going to be total interreflection. Again, it's going to be total interreflection. So this phenomena takes place, and you can take this cable for a long distance by just folding that one. So you can get the signal of light could be transmitted to the long distance using this one cables. So nowadays in communication system, they are going to use this optical fiber because speed of light is larger compared to speed of electromagnetic waves. So that electrical wave signals that you are sending, that signals has lesser. So that's why optical fiber cables are used for transferring the data. You may have heard about 5G. Is it 5G, 4G, LTA signals?
Yes,
are
sir.
there. So these signals are transmitted through these optical fiber cable using the phenomena called total internal reflection. Okay.
Yes, sir.
Okay. So I think so. I told you much more than this one. So let's move to the next concept. So that which is related to prism, sorry, refraction through the spherical surfaces. So how the refraction takes place in a spherical surface? Here I will test. Yes. Yes. Any doubt?
Sir, before starting this concept, we can take breaks, sir.
Okay. So we'll take a break.
Yes, sir.
Yeah,
It's
sir.
around.
I was about to tell you about the break. So 15
Okay,
minutes
fine.
we'll give them.
Okay, sir, fine.
Yeah, we'll start at 6:18, sir.
Okay, fine, sir. Now 6
Yes.
3 is there, 6:18.
Yes, sir.
Thank you, sir.
Yes, students. Also, in the chat box, I've shared you guys the feedback form. Please fill the feedback form. And if there are any difficulties regarding that, you can just ask me now in the session.
Sir, already done, sir.
Sorry.
Sir, already done, sir.
Thank you
I
so much,
completed.
Safin. And also, we have Learnodaya sessions will start soon, and the registrations also will start soon. We'll share you the link for that also. Within 1 or 2 weeks, it will be with you on your mail IDs and your WhatsApp. So please join that also if you are looking forward for giving your CET examinations or JEE or NEET. It will be helpful for you. That is
Yes, sir.
also
Sure, sir.
free of cost. Safin, right? You'll join. Muskan.
Yes, sir.
Arbi.
Yes, sir. Confirm, sir.
Yes,
Thank
sir.
you. Thank you so much. Were the sessions helpful for you guys? How did you
Yes,
guys
sir.
find
Really
the
helpful, sir.
lessons for the CBSE Mindspark series?
Yes, sir. Really good, sir.
Yes,
Thank
sir.
you. Thank you for your responses. So when are you guys having your examinations started?
24, sir. February
20
24.
Feb.
24th Feb. Nice. So I all the best for your examinations too.
Thank you, sir.
Thank you, sir.
I want toppers from this list, which I have Muskan, Arbia, Safin, Lavanya. Prashant is not there today, I guess. Abhinav, then Harshita. I want toppers from this list. Right?
Yes, sir.
Yes, sir.
Yes, sir.
Good. Keep up the spirits like this only. So, what are you guys planning after your 12th standard? After your, what degrees are you planning to go? Engineering, pharmacy, MBBS,
Sir, engineering
Sir,
field, sir.
defense.
defense. Who was that? Muskan.
Yes, sir.
Very good. Proud of you. So, we'll have
Thank you,
young
sir.
fighters in the army and military too.
Yes, sir.
I had a dream of that, but I have an eyesight problem, so I didn't get selected in the defense because of my eyesight. Or else today I would have been in army. But thanks to Dayanand Sagar, I've got a good scope in pharmacy. I did my pharmacy here in Dayanand Sagar University, and again now I'm pursuing my BBA. And after that, I'll pursue my MBA too in here. A college is extremely good if you guys are looking for any chances in Bangalore or you want to study in Bangalore for your further studies. You can just apply blindly in Dayanand Sagar University. Any other details, you can contact Hemant sir, and there are many more helpline numbers for our college.
Sure,
Okay,
sir.
sir.
Good. So quickly, let's see a video of a college. You guys have seen.
Time. The time proves that we have come a long way to get where we are today. Dayanand Sagar University, with the legacy of 6 decades, had contrived to the achievements today and is throwing light on the way forward. Our visionaries understood the need to learn and know, to do and grow, to twiddle and tweak, creating the best of the thinkers, creators, innovators, and inventors. In fact, we believe in achieving more than ever before, instilling the commitment to strive continuously to serve the national and global needs. There are challenges we can't ignore, but remember, we are of humankind, and every objective is achievable by setting our minds, and Dayanand Sagar molds you to achieve the objectives in an environment that enhances creativity and innovation. If we all embrace the spirit that there really is no limit, if we rise to this occasion and come together cross nations, if we integrate and ideate, we can make the future great and live the dream. Our legacy of education takes its root from our founding father, late Shri Dayanand Sagar, a visionary, an educationist, a powerhouse of knowledge and a believer in transforming the world, besides a leader par excellence. The institution has contributed to educating the world for over 60 years, carefully building alumni of over 100,000, including accomplished professionals, sports personalities, celebrities spread across the globe. We stand strong as a top-rated university, having 4 campuses with 350 teaching staff, educating 4,400 students with pride-filled and powerful alumni network across the globe. Dedicated faculty members who work across disciplines, collaborating and lifting us as the top university in the world, empowering the rising generation and nurturing entrepreneurs. Dayanand Sagar University. Live the dream.
Students, if you have any questions, you can unmute yourself and you can ask me in between. Excuse me, sir. Vinay, sir.
Yes, sir.
Yes, sir. Sir, we'll start.
Yes, sir. We'll start.
Okay, sir.
Sorry. Welcome back, students. Students, are you there?
Yes, sir.
Okay. Now, so we'll looking to refraction phenomena from a spherical surface. There is a derivation that they are asking in this question, that you know that n1, n2, u, v, and r radius of curvature. What is the relation between n1, n2, object distance, image distance, and radius of curvature r? So there are two types of refracting surface. One we called as concave surface, another one is called as convex surface. Among these two, which one is concave and which one is convex?
The first one is convex, second one is concave.
Convex and concave. So you just remember an easy method. If the surface is cave, like a pit-like structure, so that is what we call as concave surface. It is for lens also, it is for mirror also. If the mirror is like this, it could be a concave mirror. Convex mirror is bulged at the center. Like that, convex lens is also bulged at the center. Okay. Now, so we are going to consider, when reflection phenomena, we will consider a line which we call as principal axis, which passes through the optic center of the medium. So this point, which we called as optic center, and C will be the center of curvature. What is the center of curvature? It is a curved path of this surface. So distance from the center of curvature to the point P, that is called as pole, is called radius of curvature. So we can see what is the assumptions, or what could be the sign convention that you need to consider in case of a refracting through the surfaces. That you very well known that very simple, all the measurements are taken from the principal axis along the direction which we consider as positive, opposite to the direction which we consider as negative, and the images which is upward will be considered as positive, downward will be considered as negative. So like that, there will be a sign convention is there. Here only I'm going to consider one surface, that is convex surface. How the refraction takes place in a convex surface. To understand this one, I'm going to consider a convex surface where P is a pole and C is center of curvature. Now I'm going to consider an O is an object. It's a point object. Why I'm considering here point object? Because the image will be formed inside the medium. So that's why here we consider point object. So it could be easier for writing ray diagram. So now you can see that how the image will be formed, Actually, the light should move from in this direction, straight line. But thing is, what thing happens is, when light enter from rarer medium to denser medium, so it move, it bent away from the normal. So that's why, so it's going to be like this. So if I'm going to draw a normal over here, so what thing happens, you'll observe that this is angle of incidence, and you can consider this one is angle of refraction. So here this angle I'm going to consider alpha, and another one, this angle will be beta, and this angle will be gamma. So while deriving this relation, we need to consider three triangles. One is AOC and AOI. So that I'm going to consider in the next derivation steps. So I, that is exterior angle I, will be equal to sum of opposite interior angle. You can consider a triangle AOC. Opposite interior angle alpha and gamma will be is equal to what? I. So that's what I think here alpha and gamma will be I. So when it comes to the next one relation for the triangle ACI, so you can see the triangle ACI, how we are going to consider is exterior angle gamma will be sum of interior angle R and beta. You can look into these two angles. Clear? R is equal to what? Gamma minus beta. So that means when you're going to consider tan of alpha, tan of beta, and tan of gamma, so there we are going to consider alpha, beta, gamma are very small angles. So that's why tan of theta is approximately considered as theta. So that's why tan of alpha is approximately alpha. Alpha is equal to opposite by adjacent. Opposite side here in the case of tan of alpha is opposite is MA, this perpendicular line, and adjacent is OM or MO. So MA by MO. Similarly, beta will be MA by MI. Similarly, gamma will be MA by MC. Are you getting?
Yes, sir.
Okay.
Yes, sir.
Now, according to Snell's law, what does Snell's law says? Sine of angle of incidence to the sine of angle of refraction is a refractive index of the medium. So if I'm going to consider sine of I by sine of R, refractive index of second medium to first medium. Here refractive index of second medium is denser medium, that is glass. Refractive index of first medium is air. So if I'm going to consider M1, mu1 as 1 and mu2 as mu, then I can write that one as mu2 by mu1 is equal to I by R, where here I and R will be considered as small angles, like upside whatever considered tan of alpha beta. Like that here also sine of I by sine of R will be considered as I by R. Now, if I'm going to substitute the value of I and R using this relation, first what we consider I is equal to alpha minus gamma, gamma minus beta. If I'm going to substitute here, what I'm going to get will be, see, mu 1, here mu1, I value will be alpha plus gamma. So what could be the value of alpha and gamma? And mu2 will be the refractive index of the second medium by R. R is nothing but gamma minus beta. See, gamma minus beta, this one. And I means alpha plus gamma, alpha plus gamma. You are going to add this one. Then you are going to get an expression like this. And if you are going to substitute the sign convention, then you are going to get an expression which is mu1 by, just a second. Okay, mu1 by minus u plus mu2 by v, that is equal to mu2 minus mu1 by r. Or you can say that mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. So see, this is another one important derivations that may be asking many times in the competitive, your board examination. So you may know that it is important for 5 marks. Are you getting? Are you getting, students?
Yes, sir.
Okay.
Yes, sir.
So refraction through the convex surface, as usual, that you're going to observe. Like that only you can observe for the concave surface also. They're asking this one condition very rare, but you need to understand there will be a formation of virtual image. In concave surface, the image will be formed in the same side of the object because light gets reflected back. So that's why we are going to consider the image is virtual. Clear?
Yes, sir.
Okay, fine. The same relation that I'm going to explain here. Okay, next one concept comes lens maker's formula. See, there will be two more derivations are there. One is related to refraction surface, another one is lens maker's formula, another one is combination of lens. When two or more lenses are combined, what could be the effective power of the lenses? What could be the effective focal length of the lenses? That you are going to understand. To understand lens maker's formula, we need to consider lens, which is having a refractive index Okay, so which is having a refractive index mu2, which is surrounded by a air medium which has a refractive index mu1. Consider a principal axis which passes through the pole. So, or we can say that optic center that we call here as C. Here C1 and C2 are center of curvature of the surface LPN. So there may be a possibilities of there will be explained in different way. It could be explained as ABC, ADC in your classrooms. So I am explained here in the form of notation L P1 N, L P2 N, where L2 N has center of curvature C2 and L P1 N has center of curvature C1. Okay. When an object of point source which emit a light, it passes through the lens, an image will be formed at I dash or I1. So this image we consider as distance as image distance. So if I'm going to divide this one into two parts, for example, when I'm going to consider when a light ray passes from O to A due to the surface LP1N, it reaches to an image I1. Now, the expression for curved surface, refraction to the curved surface is mu1 by O to C. See, O to C, that's what the object distance, plus mu2 into mu2, that is medium, in the medium, mu2 into CI1. CI1. So that could be equal to mu2 minus mu1 by C dash or C1. This C1. This is what radius of curvature of this one surface. LP1N surface. Now for the second one surface, when you are going to consider LP2N. Now the image line, this is object for the second surface. So that's why when you are going to consider this mu2, that is the initial median, minus why we are going to consider it is in opposite direction. That's why C from the center to I1, this will be the object right now. It becomes object, and mu1 CI1. So mu1 is this one. Second median CI, final image form distance, divided by minus mu1 or mu2 minus mu1 by C2, because it is in opposite direction, center of curvature. So that is for the surface LP2N. So if you are going to add these two surfaces, this LP1N, LP2N, if you are going to add these two, or if you are going to combine these two, what are the expression that you are going to get will be C mu2 CI1, mu2 CI1. This way, if you are going to add these two cancels, and remaining thing is mu1 CO, mu1 CI. So that's what the thing remains. And substituting this one, mu2 minus mu1, here also mu2 minus mu1. The thing remains is C1, here C2 is there. 1 by CC1 plus 1 by CC2. So that is nothing but radius of curvature R1 plus R2. So if you are going to modify this one, the expression that comes for this one reaction is like this. Are you looking? Are you seeing?
Yes, sir.
Yes. 1 by minus U plus 1 by V, that is equal to mu2 minus mu1 by mu1, that is equal to 1 by R1 minus R2. So the quantity, this one quantity, what do we call this one as? This one as lens formula. What is the lens formula says is 1 by minus U plus 1 by V is 1 by F. So that's why we can write this one as 1 by F. That is the focal length of lens will be equal to mu minus 1, where mu is nothing but mu2 by mu1. Refractiveness of second medium with respect to first medium, mu2 by mu1 minus R1 by R1 minus 1 by R2. Are you getting? Student?
Yes, sir.
Okay, so here also there is a concept comes in solving the problems. Find out the focal length if the focal length of lens in air is 20 centimeter. So they are saying that the focal length of lens in air is 20 centimeter. They are asking to find out what is the focal length of lens in water. What could be the focal length in water? How to find out this one? To do that one, very simple. They are not given a radius of curvature. So here just they are given focal length in air is 20 centimeter. What could be the focal length in water? But you know that what is the refractive index of air? That is 1. Refractive index of water, that is 1.33, or you can write as 1.33 as 4 by 3. Is it? Is it student?
Yes,
Refractive index of glass could be written as 1 by 5. That could be written as 3 by 2. Is it? Is it?
Yes, sir.
So
Yes,
in the second case, refractive index, focal length of water. To find out focal length of water, what we required is refractive index of second medium. Refractive index of second medium is glass. Refractive index of first medium is water, because lens is inside the water. So that's why we need to consider mu g by mu w minus 1 into 1 by r1 minus 1 by r2. There is no changes in radius of curvature. Only the thing changes is the refractive index. So that's why what it becomes, you can see this 1 by refractive index of water is 1.5, or you can write it as 3 by 2 by 4 by 3 minus 1. The thing remains the same, so I'm just writing that one ditto. So if you are going to simplify this one, what you are going to get is that 9 by 8 minus 1. Is it? 3 3s are 9 and 4 2s are 8. Is it? Is it, student?
Yes, sir.
Now 9 by 8 is there. So if you're going to simplify by taking an LCM, 8, 9 minus 8. So that means it comes 1 by 8. Is it?
yes, sir.
So in the first initially that they are saying that when it is in A, the value of focal length is 20 centimeter. They are given 20 centimeter. So therefore, when it is in A, that means refractive index of glass 1.5 by refractive index of air is 1 minus 1. So that is 1 by R1 minus 1 by R2. Now you got another one expression. So that is refractive index of water. So that could be, so if you are going to simplify this quantity, you got 1 by 8. Is it 1 by 8 into 1 by R1 minus 1 by R2? Is it? So you can observe that 1.5 minus 1, what you are going to get? 0.5?
0.5.
0.5. If I am going to simplify by dividing these two equations, left hand side, right hand side, right hand side, 1 by R1, 1 by R2 cancels. Is it? And if you are going to divide this one, what you are going to get? I'm writing here f of W, that is focal length of W divided by 20 centimeter is equal to, so numerator what you are going to get? 0.5. Denominator what you are going to get? 1 by 8. So that is 8 into 0.5. So what is the value of 8 into 0.5? 4. Is it?
Yes, sir.
Is it? So therefore, focal length of lens in water is 4 times that of the 20. Cross multiply if you are going to. So what is the value then? Are you getting? What is the focal length inside the water? If the lens is taken in air, which is 20 centimeter, if that lens is immersed in a water, in a tank, if you are going to immerse that same lens, what could be the focal length? Its value is 80 centimeter. Are you getting how to solve this one?
Yes, sir.
Is it? Like this, you can solve many problems, which is based on lens maker's formula. So many times there could be asked in problematic part also. So when a lens is immersed in an oil, find the refractive index. The focal length in air is some value that they are given, like the 20 centimeter. In oil, they are given some focal length has in oil as some 60 or 70 centimeter. Then what could be the refractive index? They are saying of the medium, that is water. Here what we use is water. So rather than that one, they are asking find out the refractive index of the medium. Like that, you are going to get one equation which is in air, another equation which is in oil or water. So if you are going to simplify these two, you are going to get the focal length or refractive index. Okay.
Yes, sir.
Okay, fine. Now, so now coming to the concept of, sorry, one second. Have you all getting this screen is visible?
Yes, sir.
Yes,
Visible,
sir.
sir.
Fine, fine. So immediately something happens. So you can look into that. The principle of focal length, how it's going to be vary. Sorry. Okay, fine. So you can observe that there will be two focal lengths that you are going to observe. One is this direction, whereas opposite to the direction of the principal focus. If the light is a parallel beam of light, if the diverging light comes from an long distance and incident on a concave surface, it could be converging. So this could be considered as focal length f1. Here f2 is a second surface. If the parallel beam of light is coming and it could be focusing at a point, so this point will be second principal focus. First principal focus, second principal focus. So there will be a biconvex. In biconvex lens, there will be two focal lengths. One second. So it is not responding. Students, is it visible?
Yes, sir, it's visible.
Okay. Okay, fine. This is what a lens equation. Actually, that lens equation which we use in the last derivation, that is how it is going to be derived. For that one, we require a lens which is object is placed in different position. You may know about this one. It could be asking in multiple choice questions also. If the object is placed behind 2f, where the image will be formed? If the object is placed behind 2f, where the image will be formed? Can anybody?
Sir, between F and 2F.
Between f1 2f. If the
2F.
object is placed here, the image will be formed between f1 2f. Now tell me that if the object is placed exactly at 2f, image where the image will be formed? Where
At
the image,
2f.
yes, at exactly at 2f. If the object is placed between 2f and f, where the image will be formed? Where the image will be formed? Of course, it is behind the lens. Where it will be formed?
Between f2 and 2f2, sir.
No. It's behind 2f. When object is behind 2f, image will be between 2f and,
Yes, sir. Yes, sir. Yes, sir.
is it f1 2f? Like that, when the object is f1 2f, the image will be behind 2f. If I'm going to consider an object which is placed at exactly at focal length, where the image will be formed?
At infinity, sir.
At infinity. The image will be formed at infinity. You may know about that one. So the image will, these two lines never intersect. So that's why the image will be formed at infinity. We are going to consider. Clear? So it requires for an image formation position to understand image formation position. So let's go to derive about the Gaussian lens equation, how you're going to obtain the expression for relation 1 over f is equal to 1 over u by 1 over f. So here I consider two triangles. See, this is an object which is placed f1 to f, and image will be formed behind 2f, a dash, b dash. Now I consider ABC and a dash, b dash, c are the two. Which type of triangle this is? Which type of triangle these two? Is that similar triangle?
Right angle triangle.
Right angle triangle. But they are in opposite. Similar triangles? Is it similar triangles? The angle this one is same. Okay. So that's why triangle ABC and A dash B dash C are similar. So that's why we are going to get A dash B dash to the AB, these two, will be is equal to C to B dash. It's quite similar to that of tan of theta. If I'm going to consider tan of theta, how it is going to be like that. Similarly, I'm going to consider another one set of triangles. One is MCF and F2B A dash. So where we are going to consider similar triangle, and the ratio which we are going to consider is A dash B dash, A dash B dash to the AB, that is equal to B dash F divided by CF. So here going to obtain an similar triangles. Is it two similar triangles are there? So if you are going to combine these two equations, then you will get an expression like this. If you are going to obtain the Cartesian coordinate sign convention, then you are going to obtain an expression. This expression which we used in the last session, last slide, in deriving the lens maker's formula. So this formula is called as lens formula. It is not lens maker, lens formula. Are you getting?
Yes, sir.
There will be two triangle you need to consider. So I just use animations to understand those two triangles. One is ABC, and one is A dash B dash C. One is MCF, and one is AB dash F2. So like that, you can derive the expression for lens formula. So this is what I think many of you are confused. Linear magnification and angular magnification. There will be two concept comes. What is linear magnification? So it's a very simple thing. It's image to the object ratio. Image to the object ratio. What is that image to the object ratio? The size of the image to the object ratio. So that we call it as linear magnification. Here we doesn't consider how it could be, what could be the sign convention. We are not going to consider. We just consider what is the height of the image and what is the height of the object. If both are same, then the magnification is 1. If image is larger object than the object, so the magnification value is greater than 1, then the magnification is, the image will be magnified or diminished. If the magnification value is greater than 1, then what happens? Magnification is, what happens? Magnification, it could be greater than 1. Clear?
It will be positive and greater than 1. Yes, sir.
Greater than 1. Yes, greater than 1. Okay, fine. See, many of the problems when you're going to discuss, they're going to be giving a magnification and image distance and focal length. They are not giving object distance. And sometimes they are giving object distance, not giving image distance. They ask to find out the image distance. So for this one, we supposed to use these two formulas. M is equal to F minus V by F, and M is equal to F by F minus U. How you are going to find out? Just you need to substitute in this equation, where magnification is image size to the object size, where you are going to use V by U. In place of V by U, using the lens formula, that is 1 over F is equal to 1 over, so that you are going to modify these two equations. Or if possible, remember this equation, it could be easier for you. Clear?
Yes, sir.
So next one comes in concept called power of lens. That you know that there will be a, when you're going to use a specs, there will be a notation there, doctors are writing 0.5 D. What is D? D stands for diopter. Power of lens represented in diopter. What is power of lens? It's a reciprocal of focal length.
Focal length.
Or it is for mathematical expression. For if in case if they are asking to write the definition, you need to write this definition. It's an ability to bend the ray of light falling on it to reciprocate the focal length, or it's an ability to converge or diverge light rays which are falling on the lens. So that we call as power of lens. Clear? Yes, students. Okay. So here I'm going to end this. Sorry, the screen is not visible.
Yes, sir.
Just now it is visible.
Yes, sir.
Yes, sir.
Okay. The next part is that's second part, which is related to the refraction to the prism. So last I told you regarding power of lens. Do you got the power of lens concept?
Yes, sir.
Okay. So right now we are going to discuss further forward concept related to ray optics, that is reflection through the prism. After the prism, dispersion. After that one, white color is sky is blue, and then comes optical instrument, compound microscope, astronomical telescope, astronomical microscope, Newtonian microscope, sorry, Newtonian telescope. How they are going to, Galilean telescope and Newtonian telescope, how they are going to be, how you are going to write the ray diagrams with animations which I have here. Don't worry about that one. We'll start with the discussing prism. So what is a prism? That you are very well known that what is prism. Prism is a 3 triangular faces and 2 rectangular faces optical medium. So that we call it as prism. It could be an ice cube, or it could be a glass material, or it could be a diamond material. The thing is, the shape is 3 triangular faces, sorry, 2 triangular faces and 3 rectangular faces are there, means that is a prism. Clear? And there will be 2 faces which are reflecting surface, and another one face is that we call as base. Clear? See how I am showing as line by line, like that. If you are going to draw the diagrams in the examination, definitely you will be confused. Clear? So first you need to write a blue line, which is light ray incident, and come outside, and then you need to draw 2 normal lines. So you can see N1 and N2. Then mark angle of incidence and angle of emergence. Then you can mark angle of refraction R1 from the surface AB and R2 for the surface AC. Now for O, you can consider the angle O. And if I'm going to consider this one extended lines, this could be used to understand how it could be deviated. First, it is deviated like this, and second, it's going to be deviated another further angle. But the total deviation delta will be represented like this. Okay. Now, in a quadrilateral, if you are going to consider which type of quadrilateral is here, A, here A is there, P, O, Q. So for a quadrilateral, total angle is 360. For a triangle, total angle is
180 degrees.
180, sir.
Yes, for a quadrilateral, the total angle will be 360. But you can see this is a normal line. N1O is a normal. So that's why it is a 90. And this one is 90. So that's why here A plus O, that means this one A and this one O. and plus 90 plus 90. So totally becomes 360. But if you are going to add A and O, the value comes 180. Are you getting?
Yes, sir.
Okay. Next, you need to consider another one triangle OPQ. This is the triangle. There you are going to observe that the angle O R1 R2, the total angle is 180. On adding these two angles, by using these two angles, and also the concept of deviation. So delta deviation will be given by total deviation. So I1 is the angle of incidence and I2 is the another one angle. So where we are going to consider, sorry, not I2 is the another angle, which is the refracting angle. So first deviation is given by I minus I1. Second deviation is given by E minus R2. So if you are going to add both the deviations, the total deviation is given by I plus E minus R1 plus R2. So this is what the total deviation. Now, if I'm going to compare the equation 1 and 2, if you are going to compare this equation 1 and 2, A is equal to R1 plus R2. Similarly, if I'm going to compare to the equation, 1 second, I'll just lift this one out. If I'm going to compare to this equation with the equation third one, then you are going to get delta is equal to I1 plus I2, R1 plus R2 will be replaced by A. Then the deviation that you are producing will be I plus IE, that is equal to A plus delta. So now for an maximum deviation, so that is for a minimum angle of deviation, angle of minimum deviation, angle of incidence should be is equal to angle of emergence. Then you are going to get an value I is equal to R, then R1 is equal to R2, then the refraction through the prism expression becomes, so you know that N is equal to sine of A plus D by 2 divided by sine of A by 2. See, this condition you need to write. At angles, when angle of incidence is increased, at an angle of incidence where the angle of incidence is equal to angle of emergence, you can look into this graph. That condition, the emergent ray which is coming out will be same as that incident angle which will be there. So then the angle of refraction and angle of incidence expressions are obtained using Snell's law. You obtain an expression for refractive index of the medium. Are you getting something?
Yes, sir.
Okay. So this is what the small angle of incidence, what it could be. The same expression could be modified for a small angle of incidence. Delta will be variable. Next, the phenomena, I think so, it could be explained very less in your theory classes. Dispersion phenomena. What is dispersion? Dispersion is splitting of white light into its components. What are the components? 7 components are there. Majorly we consider Vidgaya, where when white light enters from one screen, one side, and when it is reflecting from another surface, it's going to be divided into 7 colors. So this phenomena that we call as dispersion phenomena. Cause for dispersion is, it's because each one medium thickness going to be varying. As usual, there will be a refracting or wavelength of the wave which is coming out will be going to be varying. So that's why. So the screen will get with a different type of Cauchy's equation. It is not required. We'll just look into this one. It is a competitive exam based concept. Dispersive power also. Just forward this one. So now coming to this concept. Remember, a shortcut method I am telling you how to write a compound microscope. When you are going to observe a microscope in your biology lab, have you seen microscope?
Yes, sir.
So there you observe 2 lenses. One is below that, there you can adjust that one, and above that will be eyepiece. Is it?
Yes, sir.
In compound microscope, objective lens, which is very small. Eyepiece is very large. Clear?
Yes.
In telescope, when you're going to consider, this will be reversed. This will be objective and this will be eyepiece. Clear?
Yes, sir.
Let us consider a light ray which is coming from the objective side. Of course, every time when you look into the microscope, there is a mirror adjustment at the bottom which reflects the light from this, which passes through the cells or whatever may be the thing that you focused in your lab. So light enter from this, and somewhere it focused between this tube. There will be a distance between objective and eyepiece that we called as length of the microscope. Okay, so when you are going to understand this one, first what you need to know about that, we need to mark focal length and twice the focal length of the objectives. So these are all the points where you are going to observe focal length, twice the focal length of the objective for this face and this face. Now if the object is kept behind or between focal length and radius of curvature or center of curvature, then where the image will be formed for this one lens, for this one lens, where the image will be formed, that you know that when object is placed in between these two, image will be formed behind
Beyond 2F.
Behind 2F0. So now when I am going to observe that, the image will be formed somewhere here behind 2F. Now when object eyepiece lens is adjusted so that the image which you are obtaining should be within the focal length, then you are going to get a virtual image. Remember, virtual image. This image, this is not an image, it is an image of objective image. A dash is objective image. Now if you are going to focus this one lens, you can observe in the next point. One second. Is it visible, student?
Yes, sir.
Okay, now you can see that where it could be focused. So A double dash, B double dash is there. This is what the image distance, where for second lens, that is for eyepiece, this is an image of objective. This will be the objective for the eyepiece, where object is placed between focal length and pole piece. Clear?
Yes, sir.
Okay, so this is what the complete diagram of compound microscope. Do you have any doubt, student? Did you have any doubt about this one?
No, sir.
No? Okay. We'll move to the next concept.
Regarding formulas in this microscope.
Yes. That's what I'm going to do. Here I'm going to mention the length. You see, what is U naught?
Object distance.
Object distance from objective.
Objective.
And what could be the V naught? Image distance to the objective. Now, what is L? L is the distance from the objective to the eyepiece. Is it?
Yes, sir.
Yes, sir.
Okay. And what is D? D is nothing but distance of vision of the eye, normal human eye distance of vision.
Okay.
Okay. Now, angular magnification, that's what I'm saying. Okay, fine. Just tell you regarding angles. Now you'll observe that when you're going to consider a parallel beam of light from an objective, so you can observe here up to here. So we consider a parallel beam from here for this object, this eyepiece. So it could be alpha. This angle should be alpha. Why we write this one is, see, now this will be the virtual object for the eyepiece. So that's why from here, if I'm going to bend the line which passes through the pole point, so this will be alpha. And actual either this one's vertical opposite image which is formed opposite A dash, A triple dash is there. For opposite this one, you'll observe that if you are going to draw this line, this will be the magnification position. So this is object height and final image height is this one. Are you getting? final image height is A dash B dash, is it? The ratio of alpha to the beta, that is, this is object and this is image. The ratio of beta by alpha. See, what is this beta by alpha is? Beta by alpha is angular magnification. Are you getting?
Yes, sir.
I'm explaining once again. You just look into the slide where I'm going to consider. See, so this is what object, is it? Object.
Yes, sir.
Final image. Of course, this is also image. And again, due to second one lens, this is first image first. Due to second one lens, will obtain an image over here. This is the final image, is it?
Yes, sir.
So this is the final image. So if I'm going to find out the ratio of height of the object to the height of the image, this is what the height of the image. So it's a linear magnification. To find out angular magnification, which we are going to observe through the eyepiece, this is what the eyepiece pole point. From here, I'm going to draw two lines. One is to the object, another one is to the image. And this angle I'm going to consider as alpha, and this angle I'm going to consider as beta. Now, beta by alpha is nothing but angular magnification. Linear magnification, if they are asking, what is linear magnification? This height of the image. A dash, B dash to the A double dash, sorry, triple dash to the A double dash. If you are going to write this one height to the this one height ratio, that gives you linear magnification. Here I require angular magnification. To find out angular magnification, I need to consider beta by alpha. Are you getting?
Yes, sir.
Now, just now, if I'm going to go to the next slide, there, what is tan of beta and tan of alpha? So now to explain this one, I require previous slide, but I am just going to write here itself. No problem. So that you know that here is the bigger lens was there, is it? So this one is eyepiece, is it? So here is the A double dash, sorry, triple dash, A double dash, and the final image B double dash, is it? And this one is alpha and this one is beta, is it?
Yes.
Now, if I'm going to consider for a magnification, tan of beta. What is tan of beta? Tan means opposite by adjacent. What is opposite side? This one.
A dash, B dash.
A dash, B dash. By adjacent side. What is this adjacent side? Is distance of vision that I told you from here to here. What could be this one is? This is the distance of vision of eyepiece. What is the distance of vision of eyepiece? Always 25 centimeters.
25 centimeter.
You can look into that any book in your table. So if you are taking that books to closer 25 centimeter above, so it will be blurred because your normal human high visibility capacity will be 25 centimeters. So that's why we are going to consider this one as D. Now for the tan of beta, that is opposite by adjacent. So you can look into that A triple dash and A double dash to the distance D. So if I'm going to consider D cancels, thing remains that will A double dash, triple dash, and D. So that could be represented as okay. Yes. Now I'm coming back to previous slide. So there we'll observe that the distance from here A double dash to the point P. So this distance could be written in terms of A dash and B dash. So where is A dash and B dash? So here the image will be formed at A dash and B dash. So A double dash, this is one is A, B double dash. because they are similar triangles. So I will show you that one in the previous slide. Just see. See, is it visible?
Yes, sir.
Look into this triangle. Look into this triangle. What I'm writing in black now. Look into this one. This one triangle is similar to that of this one triangle. Is it? Is it? A dash, B, B dash, B double dash. Similarly, B double dash, A double dash, B dash, A dash, B. Both are similar.
Yes, sir.
So,
Yes, sir.
in the terms A double dash and P could be written in terms of B. So here what I'm going to do is I'm going to replace this B by this A double dash, A dash and B dash. So now if you are going to observe in the next one, you'll observe that you can observe here the ratio could be written in terms of A dash, A double dash, B double dash, A dash, B dash, A dash, B dash by A double dash. So this ratio of A double dash, B double dash, A dash, B dash will be called as magnification of eyepiece. So there will be two lenses, one is eyepiece, another one is objective. So this could be the magnification of eyepiece. And if I'm going to consider A dash, B dash. So this is what the image formed by this one lens, objective lens, and image will be AB. So that's why if I'm going to consider this ratio, so this gives you magnification of eyepiece, sorry, magnification of objective. So according to this relation, what you are going to get is if you are going to multiply both of them, that means if you are going to multiply magnification of eyepiece and magnification of object, so that gives you total magnification, or you can write as here that they are given that they are given as 1 minus VE by PF. We are going to substitute this value. So that could be given by magnification of objective to the magnification, sorry, distance of objective to the distance of eyepiece. So this will be two different conditions. So you may be not asked for you to derive the expression, but you require these two expression to find out the magnification. This is the case for a magnification of only eyepiece. Eyepiece, if they are asking, this is the total magnification. If I'm going to consider magnification of objective, it's simple. One lens is there, this is objective. What is magnification? It is object distance, it is image distance. Means magnification is nothing but object distance, sorry, image distance to the object distance. Of course, we are going to consider negative sign. Is it? So similarly, magnification of eyepiece, where you are going to consider 1 plus D by F, because this one is obtained from the last expression that you have derived. There you are going to multiply this magnification of objective, magnification of eyepiece. Finally, we get an expression like this. So this is the final expression for magnification power of the compound microscope. Simple microscope, this is what the very simple microscope magnification is this one. Magnification of eyepiece. What is that?
Excuse me, sir.
Yes.
Sir, is compound compound microscope ka wo derivation is asked in exam?
No, it is not asked in exam. Derivation is not asked in exam, but in competitive exams and also in problem part, this relation is important.
Okay, sir. Only the formula.
Formula is important. If they are asking for compound microscope, you need to remember this formula. For simple microscope, magnification is given by this one expression, because in simple microscope only one lens is there. Your magnification glass, is it? Is it?
Yes, sir.
But here you should remember that here it will not comes minus, because See, object is placed here, where between F and pole. The image will be formed in the same direction, the same side. So that's why object is also minus U, image is also minus V. So that's why the ratio comes magnification positive. So that's why when you're using simple microscope, we get magnified image. Is that, have you used any simple microscope for diminished image? No. Always we are going to use simple microscope to magnify the image.
Yes, yes, sir.
Is it? So that's why it comes plus. Here minus is there, it will not come minus in case of simple microscope. For compound microscope, this is the expression. Clear?
Yes, sir.
Okay. We'll move for the next concept, that is astronomical telescope. Like that, similar to that of astronomical telescope, how to write the ray diagrams. First, you need to take the lenses, see what could be this one distance, remember this one distance, same distance should be this one. You should not like that you are writing lens one is like this and another one line like this. If you are writing like this, you need to bend line like this. So that's why, remember, first you write the line, first straight line, then draw the objective and draw the eyepiece, which is exactly at the middle. Okay, so this distance and this distance would be same. Clear?
Yes, sir.
Yes, sir.
Now, if you look into the next step, so what you need to do is how image will be formed in case of astronomical telescope. Remember here, there is no point object in astronomical telescope because the light rays which are coming from a long distance object are parallel lines. It is not converged line or diverged line. Clear? Many of time they are start with a point source. Don't do that one. It should be parallel lines. It could be inclined or straight, not an issue, but it could be a parallel lines. Clear?
Yes, sir.
Clear, sir.
Now, because of this objective lens, this will be focused at an image point here. Are you getting? Image point is here. Okay. So because of this object focal length and eyepiece focal length are same, this becomes an object for the eyepiece. Are you getting what I'm saying? This image is object for the eyepiece.
Yes, sir. Got it.
Okay. Are you getting? Now what I think happens if you are going to draw the lines which are passes through the principal focus, you're going to get an expression which is image which is formed like that. How the parallel lines of images object light rays comes. Similarly, the image will be obtained. Image will be obtained at infinity, but it is quite similar to that of object. Clear? Are you getting how it is could be? Are you getting? Where the image will be formed? Where the image is formed means image is formed at infinity. Of course, you can see that the object is quite larger, bigger here because it's coming from longer distance. Now you can see that the image that you obtained here is smaller. And from that one, when you're going to look into the eyepiece focal length, exactly eyepiece is at focal point. Remember, exactly eyepiece at focal point. The same height will be observed through the eyepiece, through the eye. Clear?
Yes, sir.
Okay. So now here the L will be length of the telescope, which is the summation of focal length of object to the focal length of eyepiece. So that's why when you're going to use magnification in terms of astronomical telescope, we supposed to consider this alpha, the angle of incident, and beta, that is angle of image which will form. So there will be two triangle. You can observe this one triangle. this one triangle. This is alpha, and this will be beta. So where the image will be there, beta, where the object will be there, alpha, is it? So angular magnification is what? Beta by alpha. Angular magnification. Are you getting?
Yes,
sir.
So that's why we are going to get a magnification beta by alpha will be f naught by e naught. F naught by e naught. Beta by alpha. Beta is represented by focal length of object, and alpha is represented by focal length of, beta is represented by all focal length of eyepiece. Focal length of eyepiece, and alpha is represented by focal length of object. The ratio of focal length of eyepiece to the focal length of object, that you are going to get as magnification of the astronomical telescope. Are you getting?
Yes, sir.
Okay. Now, this is a different case when you are going to observe oblique incidence. That means when you are having an image which is formed, magnified, and there will be a finite images formed means, then we need to consider a different way. So this could be the triangle where you are going to consider object distance, and image will be formed here. AB is the image. You can see this AB, this could be the image. So then you need to consider this one triangle. So where you need to consider distance of vision D and object for the second one lens is, see, UE is the object for the second one lens eyepiece. Clear? The image will be formed at D. That is nothing but V.
Yes, sir. Yes, sir.
Okay. So now if I'm going to same relation, if you're going to use, the equation is modified as M is equal to minus F by F naught into 1 plus Fe by D. Are you getting? So there will be a modification, angular modification. So because of image is formed at a finite distance. If image is formed at an infinite distance, this quantity becomes 1. Are you getting? This quantity becomes 1. So that's why FO by, that is focal length of object to the focal length of eyepiece. In the case of image formed at an infinite distance, in the case of finite distance, distance of vision D and focal length I, 1 plus Fe by D is multiplied. Okay.
Yes, sir.
Now, this is Newtonian telescope, very easy telescope. It is asking many of the exams in 2 marks questions. 2 marks questions they are going to ask. It's a reflecting telescope. What is reflecting telescope? Here, what are the telescope and microscope that you observe? Refraction phenomena takes place. What is refraction? The light fall on lens, and after the conversion, that going to be refracted. After reflection, that your image is formed. But here there is no refraction takes place, only reflection takes place. To do this one, a hollow pipe is utilized, which is one end is modified within fixed within a concave mirror. So when you are going to observe a large distance light rays from large distance, they are coming. You can see in the next slide what I'm going to say, how the image will be formed. Are you getting? So I'll show you once again. See, concave mirror is arranged like this. A plane mirror is arranged, an eyepiece, so that it should pass us through the it passes through the eyepiece, so that it could be focused in parallelly, so that to the eye. So when a light of parallel beam which is coming from large distance, then they're going to be reflected back to the plane mirror. It is what the incident light ray, it's going to be reflected back to the plane mirror, which is inclined and which is passes through the eyepiece and which enters to the eye. So this is what reflecting type Newtonian telescope. Are you getting an idea?
Yes, sir.
Another one is their Galilean telescope, where they are going to murder a small pinhole here.
Yes, sir.
Here itself here. So because after reflection, the intensity of light radiations is concentrated, it could affect the eye. So that's why Galilean loses his eye. You may know about the history of the Galilean telescope. When you are going to observe the discovery of the Galilean telescope, he loses his eye because of concentrated eye light rays which is fall on his eye. So here magnification is given by similar FO by FE. Here there is no minus sign indicated because here we are going to use mirror. All the images will be, object will be at the same side. So that's why we are going to get an FO by FE, focal length of object to the focal length of eyepiece. Clear?
Yes, sir.
Okay, let it be. This is for resolving power of microscope. Okay, so I came to an end to the ray optics concept. Do you have any doubt in ray optics concept? It's quite clear. It's quite clear.
No, sir, not.
It's quite clear.
Yes,
sir.
Yes, sir.
Shall we move to the atoms nuclei or your communication concept? Communication concept. Which one?
Atoms, nuclei.
The atom and nuclei.
Atom and nuclei. So do you don't have any communication system problem?
No, sir.
No?
No, sir.
Okay, fine. So then I'm just moving to the next one concept is atoms and nucleus. I'm just going to recap that one so that it could be useful for you in the annual examination. The slide is, yes, share. Now it is visible?
Yes, sir.
Yes, sir.
Yes. Now even look into the atoms and nuclei concept. So see, atoms and nucleus are different chapters, but I have included here atoms and nucleus are well related to each other. So that's why I'm going to explain here combinedly. So atoms chapter starts with a Rutherford alpha scattering experiment, and there will be a phenomena of alpha scattering, distance of closest approach, impact parameter, composite of nucleus, atoms, mass defects, all those things comes. So let it be, I'm just going to be directly to the concept, Rutherford alpha scattering experiment. So do you know that and radioactive substance is what? What is meant by radioactive substance? Can anybody? What is meant by radioactive substance?
So where the nucleus of atom is unstable.
Which is unstable. See, very simple. Of course, nucleus of an atom is unstable. If it is unstable means it is not, every atom is not emitting radiation. It could be just by excited and de-excited to the ground state, like that thing also happens. But what is radiation or radioactivity means spontaneous emission radiation by the nuclei, by the atom. So that we call it as radioactivity, radiation. Spontaneous emission means some of the materials which emit radiation without influence of any other, that doesn't require any heat energy, that doesn't require any chemical reaction. If an atom is present independently, that emits radiation spontaneously. So that's why that we called as radioactive material. If I'm going to consider a radioactive material inside a box, so that could be passes through the thin golden film. Some of the you can look into that. Some of the alpha particles are deviated to an angle, and many of them are passes through, and few of them could be reflected back, which has angle of reflection will be, angle of deviation will be more. If you are going to observe the gold atom by zooming, so you can see here, gold atom has something that is inside the atom that is positively charged, because alpha is positively charged. When it is an alpha particle which is passes away from the gold atom, so that is passes straight over, when it is passes quite near to the nucleus, it's going to be deviated some quantities. So like that, we'll observe that. So it's going to be passes in different angle. See here, this distance, the perpendicular distance, remember here, perpendicular distance from this main position to the this direction of alpha particle is called as impact parameter. Remember that one. Many times they are asking what is impact parameter. So impact parameter is the perpendicular distance from this main position. Clear?
Yes, sir.
Okay. So this perpendicular distance, it could be going to be increases means the angle of deviation goes to be decreases. You can see that what I think happens is when you are going to increase the distance. Now you can see here at the center exactly how it's going to be. And next, if you are going to increase the distance, how it's going to be. Next one, the angle of deviation is decreased. Again, next one will be lesser. Again, it's going to be straight line. So like that, you can observe that as the impact parameter length increases, angle of deviation will be decreases. So scattering angle and alpha particle, how they are going to be, that could be represented like this. So this is what Rutherford alpha scattering experiment explanation and experimental observations. So the points that I told you in the each line, so that could be represented and that could be explained here using the alpha scattering experiment. So there will be 3 observations that you observe. Most of the alpha particles are passes through the straight line through the gold foil, and some of the quantity, some of them are, few of them are deviated through a certain angle, which is of the order of few degrees, and one for 9,000 or 10,000, you can consider, they will be deflected more than 90 degree. One for 9,000 alpha scattering, and for few will be deviated for 180 degrees. So this is what the observation that you seen here in the this one. You'll observe that this will be straightly passes and this will be quite deviated, and some of them are more than 90 degrees and some of them are reflected back. You can see in this zoomed phenomena that you observe here, they are reflected back. So this is what the experimental observation that they are asking. So you can remember that one. And there may be another one concept called closest approach. What is meant by closest approach? That means the distance of closest approach is what could be the distance of an alpha particles which could reach us to the inner part of the atom. So if I'm going to consider, if I'm going to imagine this is what the atom, so what could be the closest distance that it could be reaches to the nucleus? So this part will be called as distance of closest approach. Clear? Clear, student?
Yes, sir.
Okay.
Yes, sir.
So it could be given by a relation that you know that the distance of closest approach is what we called as the energy which is possessed, potential energy of mv square, and electrostatic force between these 2 points, because alpha particle is nothing but
Proton.
alpha particle is nothing but photon. That is nothing but it is also positively charged. So that's why Ze, sorry, that is nothing but, you can observe here, Ze 1 by 4 pi epsilon naught q1 q2 by r square. That is what the thing when it comes to electric force. Electric potential energy is 2 Ze square divided by r naught, 2 Ze square divided by r naught. Because when I'm going to consider this an hydrogen atom, how many number of electrons in the how many number of protons inside the nucleus? 1. Is it?
Yes, sir.
If I'm going to consider gold means, what would be the Z value that you need to substitute? Okay, so that's why the radius of the nucleus, which is find out by distance of closest approach, which is given by 1 by 4 pi epsilon naught 2 Ze square, or you can represent this one as a 4, 4 gets cancelled. That could be ZE square by pi mu naught mu square. So that's what the expression for radius of the or distance of closest aperture, where u is called as initial velocity and m is called as mass of the which one? This is alpha particle mass, and epsilon naught pi is constant, and z e square that you know that if it is a gold, what's the value of z that you need to substitute. If it's a hydrogen atom, hydrogen, it's a 1 value for hydrogen. Clear?
Yes, sir.
So that I told you that what is impact parameter. So you can see this impact parameter is the distance. You will see that this is a b is the distance from the mean position. So this what we called as impact parameter. Impact parameter is the distance of the velocity vector of an alpha particle from the center of the nucleus when it is far away from the nucleus is known as impact parameter. Okay, so there's an expression to find out the impact parameter. If you possible, you just remember this formula, no need of derivation, but you remember one thing: what happens to the theta value if b value increases? If impact parameter increases, theta value decrease or increase?
Increase directly.
Decreases. See, this is a cot theta, it is not tan theta. Cot theta, that is nothing but 1 by tan theta. So that's why theta is inversely proportional to theta. Are you getting?
Yes, sir.
Okay. Okay. That you know that what is the composition of nuclei? What is the things that you observe in a nucleus? What are things in the nucleus? Well, there is a proton and neutrons. How you are going to represent that? Representation will be x. It could be represented as zx into a, where z is called as
Number
atomic,
of protons.
number of proton or atomic number, where a is called as mass number, and it could be the summation of number of protons and neutrons. So you can look into that one, number of protons and neutrons. Is it?
Yes, sir.
Okay. So now just clear this one. Okay, fine. So basic characteristics of nucleus is there. What is that basic characteristics is size of the nucleus, which is given by an Arrhenius equation. You can look into this equation. This equation R is equal to R naught into a to the power of 1 by 3. It is not 2, remember 1 by 3. This is what we called as empirical formula. Sometimes they are asking, write the empirical formula for nuclear size or nuclear radius. This is what the empirical formula. Empirical formula means it's just written. And after the writing the formula, if you are comparing, if you are going to substitute the values, you're going to get the correct value. So that's why it's an empirical formula. Clear?
Yes, sir.
So R is equal to R naught into a to the power of 1 by 3. It could be a size of the nucleus or radius of the nucleus expression, where R naught is the radius of the hydrogen atom. That is 1.2 into 10 to the power of 15. It should be 15. It's not 5 meter. It should be 15 meter. Okay. So yes, the next comes is volume of the nucleus. What is volume of the nucleus? It's a appear to be spherical. We assume to be nucleus is a spherical shape. So that's why we consider that one as 4 by 3 pi r cube. In terms in position of r, we can write it as r naught cube. That is nothing but r naught to the a to the power of 1 by 3. That becomes r naught cube into a. So that's why the volume of the nucleus depends on what? A, that is mass number. As mass number increases, volume. As mass number increases, volume increases. For an uranium, the volume is bigger. For hydrogen, volume is smaller. Clear?
Yes, sir.
Okay. So now you need to understand what is nuclear density. Is that nuclear density is different or same for all the nucleus?
It's same.
It is
same.
Why? Remember this one. Remember, this is quite important, because mass may be differ from nucleus to nucleus, because For hydrogen, only one proton is there. For uranium, 92 protons are there. So that's why mass is different. Like that, volume also different because it has only one proton, volume is smaller. Because uranium has 92 protons, the volume of the uranium also changes. So it could be appears like smaller for an hydrogen, uranium it appears volume as bigger. But the mass per volume of the nucleus for both the cases, either it could be a hydrogen or it could be uranium, remains same. So that's why if you're going to solve the expression, mass is given by A into AMU. That is nothing but you can substitute the value A. That is number of protons and number of neutrons. On the basis of that one, if you are going to compare with the volume is 4 by 3 pi r cube. R cube is represented as r naught to the a to the power 1 by 3 whole cube. That becomes r naught cube by a. So if I'm going to divide mass per volume, so mass is A and per volume is 4 by 3 pi r naught cube into A. So A cancels. Only the thing is mass per volume depends on what? 1 by 4 by 3 pi r naught cube. So all these value will be constant. R naught is constant, pi is constant, 4 by 3 is constant. So m by v, that is nothing but density of the nucleus remains constant. It doesn't depends on mass number or atomic number or size of the atom, radius of the atom. It doesn't depends on those things. It only remains constant. Its value is approximately, its value is, you can see that it's of the order of 10 to the power of 17. Of course, the value of 2.29 going to be changes. 2.29, it becomes 2.19 or 15. It depends on stability of the nucleus. But approximately, if you're going to consider, stable nucleus has constant nuclear density. Clear?
Yes, sir.
Okay, so that's what I discussed in the last session. So then the next one that we already yesterday class we did that one, mass defect and binding energy. That I told you that in the last class itself, what is mass defect is. So it's if I'm going to consider a nucleus, in that nucleus, if I'm going to having a protons, neutrons separately, if I'm going to weigh this one completely, then you're going to get some mass in stable and free state. If I'm going to separate these nucleons, that is protons separately and neutrons separately, if I'm going to consider z number of protons are there, a minus z number of neutrons are there, if you are going to measure separately and those weights, if I'm going to total this one mass and subtract this total mass, there will be a defect in mass. It's because of that mass is used for binding the nucleus. So that's what we called as binding energy. And binding energy is found out by the relation mass defect into c square. Clear?
Yes, sir.
Okay. So here, another one concept comes, mass defect could be represented in okay, this could be a general purpose that you may know about that one. Why positive charges doesn't repel each other inside the nucleus. If I'm going to consider inside the nucleus in terms of helium, if you are going to consider, how many number of protons are there?
2.
How many number of neutrons are there? 2. Is it 2 neutrons are there? Is it? Even though positive and positive charges are there inside the nucleus, they are not supposed to repel, because there is a phenomena called meson theory, which explains nuclear force, where neutron is going to be interchanging its state to proton and proton is going to be interchanging its states to neutron within a fraction of time of 10 to the power of minus 38 seconds. So that's why this theory is called as Meson-Yakova theory. This was explained by Yakova, who given name as Meson-Yakova theory. Clear?
Yes, sir.
Okay. So just skip this one. That you know that specific binding energy and binding energy curve. No need to write much more detail. You should know about this one. So when you're going to discuss binding energy of the material, on which factor it depends is mass defect. Lesser the mass, lesser will be the mass defect. Is it?
Yes, sir.
Lesser the mass, if you are going to observe that for an carbon, or if you are going to observe nitrogen, the masses are very small. When you are going to use palladium, thorium, uranium, so these masses are bigger. Is it?
Yes, sir.
So that's why what I think happens is, if I'm going to consider up to till 50 or 60, the average binding energy per nucleon goes on increases. Somewhere you'll observe some of the peaks, and then you'll observe that at a particular range of value 56, you'll observe maximum, and then you will observe there will be a constant decrease. So if you're looking into that one, to this slide, you can see. Yes, you can see that how for a different nucleus, how the energy will be differ. You can see in this helium concept, helium has a maximum peak, and again lithium gets minimum peak. It's because of odd proton and even proton. You'll observe that helium has even proton. The spinning effect here, spinning effect becomes similar, even. So that's why it's quite stable compared to lithium. What happens to the lithium? Lithium 6 has 3 protons and 3 neutrons. So odd protons and odd neutrons are there. So that's why. Similarly, here also, when you are going to observe here, nitrogen, for nitrogen N14, 7 neutrons are there, 7 protons are there. For carbon, 6 protons and 6 neutrons are there. So that's why somewhere you'll observe the peaks like this. Clear? After this, at a point at for an iron, that is 56, mass number is 56, you'll observe that maximum value of specific bending energy, that is 8.8. For above this one, we're going to observe the specific binding energy goes on decreases. Clear?
Yes, sir.
Okay. So according to this one, we'll categorize the nucleus as fission process takes place in the heavier nuclear, fusion process takes place in the lighter nuclei, and there will be a special features that you observed in the heavier nuclei, that is these places, that is smaller future, that is odd number of even number of nucleus, how they are going to modify. Then okay. So what I explained in the last points, that is explained here in the specific features using that one. You'll observe that specific binding energy for hydrogen is very small, lighter nucleus has lighter, the larger binding energy is for higher nucleus. When you observe your helium, beryllium, carbon, oxygen, and neon, so you'll observe there will be a even number of protons and neutrons are there. So there will be a peaks that you observe in some of the nucleus. They will observe depths. It's because of even nucleus. After 20 greater, after the mass number 20, the gradually binding energy goes on saturation. It going to be takes saturation up to 56. Thereafter, it will be stable nuclei. Then above 120, you'll observe that all the all the materials will be radioactive material. Specific binding energy goes on decreases, like uranium, if you're going to observe. So that behaves is what the explanation given by the specific binding energy curve. So later on, we'll observe that radioactivity. So radioactivity is a phenomenon of spontaneous emission of radiation. There will be 3 types of radiations. One is alpha, beta, gamma. So which one has a higher energy of radiation is alpha, beta, gamma energy of radiation, if you're going to observe. So how they are going to scatter, that you're going to understand. And here there is one law called as decay law of disintegration. It is also called as law of disintegration. What it says is, if the rate of disintegration, if you are going to consider at any instant, it is directly proportional to number of nuclei present at that instant. If you are considering 100 nucleus, the rate of disintegration, which is depends on 100. If you find out thousands of nucleus, it depends on number of nucleus at that time. So clear?
Yes,
Hello.
sir.
So for this one, you will get a derivation and you will get an expression n is equal to n naught into e to the power of minus lambda t. So this is what decay law expression. Please make note of this one. This is quite important derivation. It could be asking for 3 marks question. Okay, here you need to know about this integration concept. Here I have not mentioned the integration symbol, but you need to know about the integration. Somehow you are a second PU student, you know about that integration concept. I think so, no issue in integration. Is it?
Yes, sir, we know.
If you are going to do the integration, 1
Yes,
by
sir.
n is log of n, and integration of lambda will be lambda into t plus c, where c is called as integration constant. So that's why you're going to get the value of the equation like this. If you're going to consider t for 0, then the expression becomes like this. In the place of c, you're going to replace this value and you'll get the expression like this. And final expression will be n is equal to n naught into e to the power of minus lambda t. Are you getting?
Yes, sir.
Okay.
Yes, sir.
Okay, we'll move forward. So that you know that half-life period, what is half-life period, mean life period. So it's a time required for to decay half of its initial value. The expression for half-life period will be t is equal to 0.693 divided by lambda. Problems based on this half-life period will be important. Please look into that one. Clear?
It's created, sir.
Okay. Next one is no need of this one. Here they are going to use a unit. Sometimes they are going to ask you what is a SI unit. If they are asking, don't write Curie is the SI unit. Remember, radioactive SI unit is becquerel. Clear?
Yes, sir.
1 year, many of them
Yes, sir.
are argued that it's in Curie. Curie is a derived, as like force is nothing but kg meter square per second square. Conveniently, we consider as a Newton as a derived form SI unit. So like that here, Curie is also considered as a derived form because radioactivity is huge part. Because every time you cannot consider one disintegration per second, once disintegration per second. So for that one, we consider 1 Curie is 3.7 into 10 to the power of 10 disintegration per second. So that will be 1 Curie value. Clear? 1 Rutherford is 10 to the power of 6 disintegration per second. 1 Rutherford is. Okay, 1 Curie is 3.7 into 10 to the power of 4 Rutherford, or 3.7 into 10 to the power of 10 becquerel, or disintegration per second. Okay?
Yes, sir.
And this one, you know that I think so. Time is up. Yeah, another 10 minutes is there. Let it be, because
Sir, we still have 8 minutes, sir.
Okay, sir. Fine, not an issue.
Yes, sir.
I have prepared another one video to understand regarding communication concept. I'll just show you that one also. We just look into the chain reaction, how it takes place. You know that when a fast-moving neutron bombarded with a heavier nuclei, this forms and 3 lighter nuclei, which again continuously chain reaction takes place to form an uncontrolled chain reaction. If it could be taking place in a nuclear reactor, that will be controlled chain reaction, where these neutrons, fast mu neutrons, are absorbed by the control rods. So that you're going to understand using nuclear reactor. So where nuclear fusion takes place. Nuclear fusion will be takes place in sun's atmosphere. Clear?
Yes, sir.
Okay. So just give me 2 minutes. Just a second. I'll show you that one also. This was a communication. If the screen is available. Yes, the screen is visible.
Yes, sir, it's visible.
Okay, fine. Okay, fine. Now it is visible.
Yes, sir.
Very small chapter, communication system will be there. You may know about that one. Basics of communications. What are the things that you observe? What is amplitude modulation? And another one concept that comes, how you are going to transfer the data. So basic communications has the components, which is having basic communication system. First, you need to know about the source of information that could be transmitted to the transmitter, and that could be received by the receiver. And you can observe that the basic information, which will be in the form of anything, that is pictures, symbols, codes, words, whatever the things, that could be transmitted through the transducer through a channel that we call a link that you are going to observe, where it is received by the receiver and it will reach us to the destination. It is the thing happens in our day-to-day life. How in digital electronics that's going to be happen. So to understand that one, so there will be a different devices that you are going to use: radio broadcasting, TV broadcasting, telephone, telegraph, radio, sonar, fax, all this, email, printing, telemeter, mobile phones, everything that will be use this basic principle. So that is communication of cable communication, ground communication, skywave communication, satellite communication, and optical fiber communications. So here, just going to skip this one because here I'm going to compare analog signals and digital signals. We are actually analyzing the digital signals because in semiconductors, how these digital signals will be produced that you discussed using AND, OR, and NAT gates that you need to remember. Do you know that one?
Yes, sir, and gates and all gates.
Yes, there will be a zeros, ones, like that. There will be a output will be coming. On the basis of that one, you'll want to observe digital signals or digital waves. Now we'll observe that modulator. What is modulator? See, the audio frequency that is yours, sending will be a lower frequency. So that will be mixed with a higher frequency. So that it's a process of carrier waves. It will be called as carrier waves. It will be transferred to the medium. That could be air medium, or it could be a conducting medium like cable or optical fiber. And this modulation will be takes place in two ways. One is amplitude modulation, another one is frequency modulation. Another one is that is pulse modulation. It could be a quite complicated one, which you are going to study in the higher classes. So here, amplitude modulation. What is meant by amplitude modulation? See, there will be two waves. One is what we speak. If I'm going to say that the speaking will be having lower frequency, the carrier waves has higher frequency. So these two will be mix up and forms a resultant frequency of wave that looks like this. So this one we consider as, you may remember, Beats phenomena in first POC. Can you remember that Beats phenomena? Two frequencies of different frequency, if they are vibrating together, that forms a Beats phenomena. So these compound amplitude modulated waves will be transversed through the medium, and which is carried through the modulator, and Demodulated means again you will get the signal retrieved. So then you will get the signal transmission in a case of modulation, amplitude modulation. So it could be the signal transmission mode. Actually, I was planned to explain it in detail because you are asked in the last class. Okay, let it be, not any problem. Power amplification. Okay, so let it be. If you have any doubts, let it be. I will send you the materials related to this one. If you have anything, is there any doubts apart from this one that you have discussed in this class? Students?
The history is loop.
Sorry? Sorry, students? Is there anything that you need? See, one thing that I would like to conclude is, see, whatever maybe the thing that we teach is a 20% effort. See, the 80% effort you need to do. So you need to see the previous year question papers, and also you need to judge the questions and also work out the problems. I told you the shortcut method to work out. First, make a preparation of formula list, paste it in your reading places, and try to solve the problems using the same problems that you did in notes, just changing the values. If the acceleration value is 3, you just change it to 4 and do it the same problems. You'll definitely get the answer, and you'll get know how to solve this one, because you are not allowed to carry the calculator in the examination. That's why the values which they are given in the examination will be quite simple, so that it will be easily dividable. If you found some difficulty, you need to be strong in calculation, because all you did, but finally if you are not obtaining a result or what you required is, then your marks will be better 1 or 2. So that's why look into that one, work out the problems. Many of them are lagging in the problems, so that's why you just work out the problems that you worked in the classrooms, and also which I discussed in the last classes also. So then definitely you will get succeeded in the examination. Okay, students, is there anything
Yes,
that
sir.
you would like to discuss? Hello, sir.
Yes, sir.
Okay, sir.
So are we done, sir?
Yes, sir. I'm done.
Okay. Okay. Thank you so much, sir, for the session.
Okay, fine, sir.
Students were also interested for this session, and they liked it. They were asking many questions. I have never seen them so interactive in earlier sessions.
Fine, sir. Fine, sir.
Thank you so much, students.
Thank you, students. Thank
Yes.
you, sir.
Thank you so much, sir.
Thank you so much, sir.
Yeah. So, students, I have an announcement for you guys. Once again, I repeating that we are starting with Learnodaya sessions shortly, and the registration link will be sent to you by mail or on your WhatsApp number. So please register on that. It will be beneficial for you for your CET programs, NEET, JEE, all your community exams. Okay.
Yes, sir.
Okay, sir.
Yes, sir.
All the best. All the best for your exams. Do well.
Thanks for this program launching, sir.
You're welcome. And don't forget to fill the feedback forms. Safin has already did. And I want Abia, Muskan, Abhinav. You fill the feedback form, Muskan?
Sir, I didn't receive.
Actually, I have shared it on chat box. You didn't see? Just a minute, I'll share it again. Please go through it. Any doubts? Anything?
Sir, can you please ask Srinath sir to send the PDFs?
Yeah, I have already asked him. He'll send it to me, I guess today evening, he told. He'll send it to me. Chemistry, I have already shared.
Yes, thanks a lot for that, sir.
Okay. Yeah. Muskan, I have shared the feedback form link. Please go through it, fill it.
Sir,
Okay, I'll end
didn't
the session.
received.
You didn't receive. Okay, just a minute. Check now.
Received now.
Yeah.
Yes, sir, received.
Yeah. So fill that form, and also we are going to conduct same MindSpark series for PUC. I mean 11th and 12th state board people. So if there are any of your friends in state board PUC, you can ask them to start registering for that. We are starting from 23rd of Feb till 26th of Feb. Okay.
Okay, sir.
Yeah. Okay. So now you guys can leave. I'll ask Vinay sir also to share the notes of today and yesterday both, and I'll share it with you on the WhatsApp group. All right.
Thank you, sir. Thank you so much, sir.
Yes, sir.
Thank you so much.
Good night.
All the best. Good night.
Bye, sir.
Thank you so much,
Thank you, sir.
sir.
Bye, sir.
Welcome, welcome, guys. Welcome.